In this video, we are going to complete the relational modeling topic, which we have started 2 weeks ago. And we will come back to certain principles that we have learned in the previous two videos and also bring in certain new things as well here. So we will start by designing and loading a relational database. We will answer some business questions using joins and analytic queries. And we will complete this video today with this lecture today with visualizing the results with a package dbplyr in R. So our um, design for today would be our how to say roadmap for today would be to design a database. We'll then load the database. We'll then move on to querying the database, obviously, and we will end by visualizing this data using R later. So that's in a nutshell what we want to do today. So how are we going to do that? We will take the role of an analyst, if we can say so, for a campus bookshop. We'll take the role of an analyst for a campus bookshop. Let's suppose, to make things a little bit easy, where you have three different campuses, and we'll build a tiny operational database, answer the manager's questions using what we have already done before, joins, plus some analytics in SQL. And then we will visualize these answers with dbplyr in R. So what we will focus today is mainly on the practical aspect rather than any theoretical aspect. To achieve what we want, you will see that I have posted on Google Classroom four different CSV files that will be the basis for our relational database. And we will upload these different files in MySQL, and we will run joins and everything there. Okay, so we have here, for example, let me just go through this quickly so that you get an idea. As I mentioned to you, we will deal with three different campuses, as you will observe here. You'll see that there are three different campuses. There is the North, the South, and the Central campus. Then we will have the different products. For that this bookshop sells, you have notebook A5, blue ball pen, USB drive, or whatever it is. These are the different products, and we also have information about their category and also their unit price, how much they cost, and so on. Then we will have the sales item. Here we go. So you will see what sale we had. For example, there is a person who bought product 101 and product 102, and he bought three rather product of 101, and he bought only one product 103. So you see these are different tables which have got relationship among each other, as you would note, because on the other side you have the product ID. 101 and 103 are notebook and USB drive. See, 101 are notebook and USB drive. So you will see that one person bought a combination of quantities for these two different items. Then we will move on to sales information, where you have the different sales ID. You have a campus ID, you have a sale date and the pay method of these different individuals, how they paid and so on. The sales ID one, you will see that he bought it from campus ID one and at whatever date, as you see here, and it made payment by cash or whatever. We have all these different information pertaining to transactions from the campus bookshop, as you are seeing. Now, having said so, we can open MySQL. Now that MySQL Workbench is open, we can click here and start uh, creating the different tables that we have. We will have four different tables, obviously. As you would recall, we will have four different tables that will include these different information that you see here: campuses, products, sales item, and campuses, product, sales item, and sales. Uh, you would need to recall what are the different columns, what are the different information that you have. Maybe I will just open it to facilitate things here. So that would make life a little bit easier when we want to create our database. So I'll just move that on the side here. So we'll start by creating our database now. Okay. And we will work on that henceforth. So let us start. We'll do create database and we will give it a name. We'll call it campus shop. This is going to be our campus shop database. Always put the same column when you finish a line to start a new line, okay? And then don't forget we need to use the campus shop as you are seeing here. So just doing that will create our database. As you can see, you refresh, you will see that the shop database has been created. Obviously, there is nothing here, so we'll need to start creating the tables with their appropriate data type and everything. At the same time, this session serves as a revision and a recap of previous lectures. If ever you did not understand a little bit about how to create a database, hopefully by now you should be able to do so, how to create a database and how to create a table in MySQL. By now, you should be able to do so. So to create the table, I've got different tables that I want to create. As you would recall, I want to create, for example, the campus table. And the campus table has got these different information. You have the campus ID and you've got the name of a campus. So what I will do, I will create a table called campus, and in campus I will include whatever information I want. What are these information that I want? For example, I want a campus ID as we just saw, and I want the campus name as we just saw. But just putting that will not work. We'll need to create table, by the way, excuse me. We need to create table campus, and then for the campus ID I need to put an data type, and also you will see that this primary key is very important, because here what happened is that this primary key serves not only as an index as I mentioned earlier, but it also is the backbone of what we are doing, because that primary key can be also related to a foreign key somewhere else in a different table. So this is basically these keys that will enable me to join the different tables at some point in time. That primary key implies a unique attribute. It means that every campus should be unique. Every campus ID would be unique in that data. So where all these different things that I mentioned about primary key constraint. So we move on to campus name. The campus name, if you look at the campus name, it's not lengthy, but we can consider it as voucher. I guess by now you should understand these different things. Voucher, I can put it as 40, 30. I can even put it as 12 or something like that. But let me just put it 60 arbitrarily here. Not arbitrarily necessarily, but something that goes beyond the number of characters that you have for campus name. So let's put it as 60. You could also put it as less. It's okay. I guess 30 should be fine, but let me just put it as 60 here. And one thing that I want to ensure is that there is a name for each campus. I don't want to have a situation that there is no name. I can't just have a campus ID and then this is a blank one. I need to have a name compulsorily for each campus. So this is where I put the not null constraint. And not only do I put the not null constraint, I need to ensure, for example, that my campus a name are not the same for a particular ID. For example, I can't have a North Campus again here. To avoid this issue, I bring in a unique constraint. Okay, I bring in a unique constraint. Don't worry about the primary key. The primary key is already a unique constraint, so you don't need to worry about that. But here, the primary key here is also not null, so you don't need to worry about that. But in the case of a campus, so you need to enforce a name, and the name should be unique. So that's one thing that we do. We are applying the concept of constraints as you are seeing here. And by doing all these, we are ensuring data quality by design here. We are ensuring data quality by bringing in this primary key, foreign key, a unique constraint, or whatever constraint that I'm going to mention. You are ensuring data quality in your database design so that you don't have anything that is blank to be loaded. For example, if this was blank and I've put the not null constraint, when I'm going to load the data, I will get a warning telling me that this is not possible or there is a problem, whatever it is. But the advantage here in this example is that we don't have this issue. So I'll just close that and move on to the next one. The next table I want to create is for the products table. This is a products table. I want to create a table that includes these different things. So you have a product ID, the product name, the category, and the unit price. So let's do the same thing. I'll give it the name of product, and product ID will be again an integer with primary key. I will have the product name. The product name will again be a voucher, but let me just check the product name quickly. So the product name are like that. Again, I don't think it goes beyond 60 characters, 30 characters. I can keep it as it is here. But the product name, you can leave it as you want. You can keep it as unique. You may want to ensure that the product name are unique. It's because especially if a product name is associated to a product ID, and if there is no duplicate product ID because it is a primary key, you can keep it as unique. You may also wish to remove it. It's up to you. You can keep it as unique if you want. And then not null is important to ensure that there is a product name, but there is no blank or anything because an ID should be accompanied by product name. All these ensure data quality. Then you have the category again. So what I will do is that I will repeat that step here, and I will put that here and change that maybe to 30 this time because the category is very short characters: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 is not bad, so I can keep it short. Maybe for this one, just to ensure that there is no issue, I can increase that a little bit, or I can leave it as it is. Let's keep it as it is. Then this is going to be category, by the way, as you see, and then you have a unit price. And the unit price here is a set of integer values that you see. But if you want, you can also make it as, how do we say, as a decimal value if you want. Just for the sake of showing you something a little bit different, I can make the unit price as a decimal value, right? Just in case if there are any price, if this database were to be adding more information, you may wish to have a decimal value included. If you want to have, this is not necessary in this, is not necessary in this example, but if you want to allow for a decimal value, you can put it as 10, let's suppose, 10 and 2, let's suppose. But that is not necessary in our example because we don't really have decimal values. But in theory, a unit price may include decimal places. So that's why I'm keeping it as it is here. And don't forget, we will need to do not null constraint as well. The not null again because I want to ensure that the price is enforced. By putting this not null, I ensure that the price is enforced, but I also want to ensure something else by adding another constraint to it by making a way that I don't get a negative unit price. For example, if the data is loaded, let's suppose by mistake I put something like negative 60 here. And then when I'm going to load that data, I know that through that check constraint, this is not going to be allowed, for example. So now you have to be careful. When you're designing a database, generally, you don't necessarily need to know what are the different values that you have, what are the different information that you have. So, for example, you may not have access to this information, but you know that you need the unit price. This is why you will put the decimal here. You don't necessarily need to put integer because you know that you will have only the whole number values. So you also need to ensure that when new information will be included in our database, these new information abide by our constraints that we have set so that we don't have a data that are inconsistent or inaccurate or whatever it is. So generally when you are designing that, we don't need to check that each time. It's just in your mind that you know that unit price should be possibility of having decimal, it should be not null, but also I want to ensure that this unit price does not include any negative value, for example. That's one check that I might want to do. So I'm applying here the check constraint of unit price being greater than 0, as you are seeing. So these are the different things that I can do here in that database so far. Now I will just go one step below and then close this here. And then, so if you want, I can run these two and see if there are no mistake. I run these two tables, execute them, and as long as there are no mistakes, that's fine. You can refresh. You will see that now two tables appear, campus and product. Obviously, if you click on campus, this would be blank. There is nothing here for the time being. We'll populate that later. But at least you can get more information in terms of campus ID. You see that it is a primary key, campus name, you see that it is a voucher, things like that. So let me complete the two additional tables that I need to include. I've done product, I've done campus. Let me do now. Let me just close product first. Now what I want to do is to create the same thing for sales here. For the sales table, you have a sale ID, you have a sale date, you have a campus ID, you have a pay method. But you will observe something is that there is the sale ID here, isn't it? So, very sorry, the campus ID here, isn't it? Now, this campus ID is very important that you understand something. This campus ID implies what? It is going to be, in our example here, a foreign key. This campus ID is going to be a foreign key for that previous table that we just worked earlier, that is for the campus table that you have here. All right, for the campus table. So here it is a primary key, but now it is going to be a foreign key. So let's create that table now. That would be the table sale. I can just get all this. Let me just copy that because this would be a bit similar. So we have here sale ID now, which is our primary key. Have a sale ID. You have this is not, sorry, this is not the table that I want. So you have a sale ID. You have just give me a second with you. Sale date, the campus ID, the payment method, and so on. Now for the sale date, by the way, for sale ID, it is integer primary. For the sale date, obviously, you will ensure we can remove the unique constraint logically because there might be different people buying on the same date. So, but for the sale date, because it is a date, we will put it as date as our data type. Date is use our as our data type, and then you have a campus ID here, and you have a pay method. Campus ID, which is integer, but it is not our primary key, obviously. And you can include it as not null again to enforce that we don't have a missing information included. And the last one is pay method. Now, the pay method have only these different possibilities. You have cash, you have card, and you have online. These are the only possibilities. To be able to define such type of possibilities where somebody else cannot write anything else apart from that. For example, somebody else cannot come and write cards with S, for example, or somebody else come and write some other thing. You can use the enum data type here. You can use the enum data type. So let me just write that down. Pay method, and enum can be used where you include the different um, possibilities that this pay method can take. For our example, it is written cash, card, and online. We write it exactly as it is, please. Even though the capital letter or small letter doesn't matter much, but we write it as it is. And again, we may enforce that not null constraint. Now we have an additional thing to do. That's why I put comma here. What is this additional thing that I want to do? Is that you would recall in relational modeling, there is a relationship that we have between sales and we have a relationship between sale and campus. All right. We have a relationship between sale and campus. So what do we want to do is that we want to bring in that relationship between sale and campus. How can I bring in that relationship between sale and campus? It is obviously through the foreign key that you have learned. So we are going to bring this in foreign key. And then we can use it, we can do it in different way using constraint, but we can also do it as it is here. The foreign key is going to be for campus ID. And that foreign key is referencing a different foreign key from referencing the same foreign key rather, sorry, from what table? From the campus table. It is referencing this particular campus ID here. So this is how I write this down. There we go. That is how I create a sale table. In this particular example, by the way, you will see that all the three normal forms are being considered. All the three normal forms are being considered. Okay. While the three normal forms are being considered, you would observe, for example, that there is a first normal form, there is a second normal form, there is a third normal form. All of these are being considered here. Let me open the sales item here so that you get it clearly. You will see that, for example, in this case here, there is only one sale per row. There is an atomic attributes in the sense that, for example, you do not have a situation where, for example, you have cash and card, which includes two possible information for a particular row. This is not here. You will see that there is only one sale per row, which includes an atomic attribute. All right. So you have the atomic attributes being considered. The second thing is that you will see that the sales ID, which is our primary key, is here. And then all the non-key attributes, that is sales date, campus ID, and payment method, depend fully, there is full functional dependency on that sale ID. You will see that there is full functional dependency on that particular sale ID. Sales date depends fully on sales ID, campus ID depend fully on that, and pay method depend fully on sales ID. So when you have a pay method given to you, this cash, you have a campus ID, you have a sale ID, it relates fully on that sales, you have a sale date, sorry, it relates fully on that sale ID. Then you have a third normal form that is included here, where you will see that campus ID here in our example is a foreign key. But sale date or pay method, the sale date or pay method do not depend on the campus ID. You see, the sale date and the pay method do not depend on the campus ID. They do not depend on the campus ID through any other attribute that you have here. They do not depend on the campus ID for any attribute that you have here. They fully depend on the sales ID, as I mentioned to you, but they do not depend on any other attribute that you have. All right. So what happened here? You will see that um, uh, the campus name has not been included, for example, here. If campus name was included, let's suppose I included campus name here, what would happen? Campus name depends on campus ID. So if it depends on campus ID, there would be transitive dependency. But because it does, there is nothing else that depends on that campus ID through our foreign key that you see here. It means that there is no transitive dependency. If there is no transitive dependency, we that is by how can we achieve that? By keeping campus name out of this table to avoid any redundancy. We have been able to achieve the third normal form. So in that particular table, you will see that there are all the three normal forms being considered. The first, we have been able to reach to the third normal form as well. And the same thing applies for product. You can just check it out on your own, and I leave it to you to ponder on that. So you will see that all the normal forms are being considered. That's something I wanted to talk about. Now we can move on. We create now a table for sale item, where you have the different information which are sale ID, product ID, and quantity. So we have a sale ID, which is an integer and not null. You will see that now I can't consider sale ID as a primary key, because here obviously if I consider sale ID as a primary key in that particular example, it won't work because I can have repeated sales by the same individual, but for example, a single person has bought two different products with two different quantities. So that's why I cannot put it as a primary key in this particular example. All right. Then you have the product ID. You have the product ID, which is again integer and not null. And you have a quantity, which is again integer and not null. But the quantity, I can ensure that I don't have a negative quantity. I can add the check constraint where I say quantity is greater than 0. That ensures that I have no issues. But we can still create a primary key. What would be the primary key that I want to create? You will see that here a single value cannot act as a primary key for sale ID because it is a repeated value, for example. But you can use a combination of sale ID and product ID to be able to create a primary key. That is what I referred to as a composite primary key earlier in my previous video. So I can create a composite primary key by writing it like this, primary key, and then I will put in between bracket the sale ID, and I will put the product ID. The combination of product ID and sale ID will create our primary key. For example, you will see that these two together, they are unique. This is together is unique. This is together is unique. So you have here a primary key which is defined through a combination of two different fields in that data. Then you can create your foreign key, but you will need to be careful here because we do not have a single foreign key in that particular example. What are our two foreign keys that we have? Just run this. You will see that in that particular example, there is product ID, which is one of the foreign key that relates to a primary key from that particular table. And then you have sale ID, which is our foreign key that relates to the sale ID from that particular table. So we have two different foreign keys now. This is why I'm going to write it down as foreign key, and then I will put sale ID here. And for this one, it's going to be product ID. And I just say what they references, which table do they reference. The references the references what? The references the sale ID from a different table. They reference the product ID from a different table. What is a table that sales ID references? The tables, not sales item, but rather it comes from the primary key here, which is sale. So this refers to sale, the primary key, and the product ID refers to that table product here, which the primary key is the same as the foreign key here. Then we can close this and don't forget the comma here. We can run these last two tables that I did not run earlier just to check if this works. So we refresh. Just give me a second with you. Don't worry about what I just did earlier because I've had some issues that I have to solve in between the videos. So here we go. You will see that now you have sale and sale item available and the campus available. Our next step is obviously to populate that database. All right, for that, we will import our CSV. Let us now import our CSV. We'll start by the campus table. I right click on campus and I do table data import wizard. Get something like that. I will go and locate where the CSV is found. Campus is from that campus table. We click next. We use existing table. I'm not going to create a new table because the existing table already has my two information here handy. Okay. So we do next. We want just to ensure that campus ID relates to campus ID and campus name relates to campus name. We click next, 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 and then free records imported. So there is no issue. Click on finish. You can refresh and just verify briefly by clicking on that icon here where my mouse is located. You would see where my mouse is located right now. Just check, and then you will see that it has loaded perfectly well. We'll do the same thing now for product. Right click, table import wizard, browse, products, next, next. Just check if everything is okay. But then look at this one, it's okay. 1 to 105, then we click next, and then we click next, and then we click next again, and you see that it tells us free records imported. So there is a problem somewhere. We click on finish. What is the problem? Let me just click here. If you click here, you will see that there is 101, 103, and 104, 5 being included. So why is this so? Let's go back to the table product. There are two things we need to check. We go back to our definition that we made here, and we go back to our table, original table, how it looked like before, to understand better where the mistake is so that we can solve the issue. So for example, here you will see that I have written, let me just put that here. You will see that primary key, you have no problem with that. There is a single value for everywhere. You have product name, voucher, not null, unique. No problem, product name, voucher, not all are unique, it's fine. Let's have a look at category. You have category voucher 30 seems okay, but not null, it's okay, but there is a unique here and we have an issue here. You will see that there is an issue where there are stationary repeated twice, tech repeated twice, and merge repeated twice. So this 106 will disappear, this 104 will disappear, and this 102 will disappear from the database when you're loading it because of that unique constraint. So what we need to do is to correct for that unique constraint. There is a way of amending and updating a table, but just to make things a little bit faster here, I'm just going to drop that whole database. Okay, drop that just to avoid going through the full explanation. And I'm going to run this again. All right, but there is another way of doing that. I'm not going to get into that right now. We refresh, and then now we can just load our data as usual. All right, that should work. Let me just load the product now. First of all, let's just check if there is nothing. There is nothing. So we're going to load that product table. So we do table data import wizard. We come back here. Click next. Now this should work. We ensure that everything is fine. We click next. We click next. And we click next again, and then now you see that 6 record imported, so it's fine, perfectly well done. So here we go, we have all our unit prices loaded correctly. Of course, don't forget to do the same thing for campus. I'm repeating myself here, so I will put the video on a pause, and we will I will load the campus before I move on to sale and sale item. Now that this is done for campus, you can check it's working well. I've already done it. We do the same thing for sales quickly. Hopefully we don't have any issue here. So we have 101 up to 105. Check all this quickly. Ten records imported correctly. So we can just briefly have a look at the table here. Sale. Sorry. Here we go. You will see that there are 10 records imported correctly. That's fine. We click finish, and then you can just briefly have a look at it. You will see that all the 10 records are imported well. So the next step is to import sales. Sales item rather, excuse me. Sixteen records imported. We can just have a brief look at it. So you have 16 records imported without any issue. So all is fine for these different examples. I'm going to teach you a new thing now. If ever you don't want to repeat that old process of going through and loading this data again and again, you can do a backup of your data. So to do a backup of your data, you will go to server, and then you will do data export. Right? You do data export. When you do your data export, you can click on your campus shop database, and then you will say export to self-contained file. You click on export self-contained file, and then you will select where you want to export that. For example, me, I want to select to export it in here. I will call it campus database backup, for example. I click save here. And then when I'm doing that, the advantage with this procedure is that I don't need to go through that process of loading the data one by one each and every time. Okay. So I can include the create schema in there. By including the create schema, it means that it will include this name of campus shop. When you are running the code later, it will become very straightforward. So then I click start export. Don't need to worry about that. Four of four exported. So what normally would happen is that in your folder, you should now see something like campus, where is it? Backup here. You see campus database backup, you see it there. Let me just suppose I want to open the whole thing and drop the campus shop now. I drop it completely and I want to load it again. Maybe I will close all this. Just save that just in case. So if I want to load everything, so I just drop that. So if I want to load everything, it's very simple. I just click on a plus sign here to click a new editor. And then I just need to open that backup that I've created. I open the backup that I've just created. You will see campus database backup. I open that. Here it creates the old backup for me, and I can just run the whole thing without worrying too much about all these words, what they mean. You don't need to understand, it's not necessary, but we need to understand what all these are. But we can just run the whole thing, and then when the whole thing has been run, we wait for a moment, we refresh, and then we can see that our database backup has worked well. You can click on campus, you will see that campus is okay. You can click on sales item just to see if the data has been loaded correctly. So that makes life far easier. So if you want to get your database backup again and again and open it, you can do that backup, and then you can click a new editor and start working on your new editor to create your join or whatever you want. That's a small tip if ever you want to avoid going through that step of table import each and every time. Let us now create a base join that will calculate the line revenue. That is the quantity times the unit price. For that, I expect to have a table where I will have different information. I will have, obviously, let's suppose, a sales ID. I will have the product ID, all right, the sale ID. I come here just to show you. You will have the sale ID, the product ID. Of course, if I have a sale ID and the product ID, I would also want to have a product name that would obtain here, that I would obtain from this table now. The product name, and I would also want their category. I would like to have the quantity that normally would be obtained from the sale table. I would like to have not the sale table, sorry, but rather from the sale item table rather. I would have a quantity here that is obtained from the sale item table, and the price per unit that I obtain from the product table with that of the quantity both from the sale item table. So you see that these two information are on two different tables. So if you want the line revenue, you will need to bring these two different tables in only a single table. So what I want to do then is to have a table that contains all these information, and I also want a table that will include the date, the sale date that you have here. It will include the date, it will include the pay method as well, and it will also include the campus. So you see that we are involving right now several tables in only one grand base join that I'm going to do. Okay, let me just um, create a new one here. So here we go. To do that, let us start by our select, and we state what do we want. As I mentioned to you, I want my sale ID. By the way, if I want the sale ID, I can just write the sale ID using by typing it. Or if you want, there is another small tip I want to give you is that you go to the column where you have the sale ID and you double click on it. That will give you the sale ID. I also want the product ID, as you will see. I also want the product name just next to the product ID. So I go to the product name here. I also want, but before I move on, you see, the moment that we have started by typing sale ID and product ID, which are found in the sale item table, and now that I'm moving to the product name table, and I know that to be able to have a final table that include the information from different tables, like here, product and sales item, you will need to use a join. But as I mentioned to you in previous classes, is that when you are using the join, it is essential that you use alias, an alias that will represent the sale ID coming from whatever particular table. For example, you see sale ID normally occurs in the sale table, but it also occurs in the sale item table. So if I want the sale ID here, I'm referring mainly to the sale item table. So I will say SI dot, I'll just call it SI to be the alias used for sale item. And product ID is again found from the SI table, as you will see. But product name is not from SI, but it is from product table. I will normally call P, but I will have to define these alias later. I'm not yet there. I will define that afterward. Then I need to write the product category, as you will see. And obviously, I write it with the alias P again, as you are seeing. Then I would need the quantity to be able to obtain the so you will have the natural order. You may wish not to include that as well, but I'm just want to put that here. So you have a sales ID, the product ID, the product name, the product category. But I also want the quantity from that particular sale item. Sorry. So that particular quantity here, it is found from the sale item table. So I use the alias SI, and then I move on. And the next thing that I want is the price, unit price, as you are seeing here. So I double click here, I put the unit price, and it is found from the table product that I will define as P, that I'm using the alias P to define product table. So all these are basically what you want, but then of course, from that uh, two main information that you have here, you want to compute SI quantity multiplied by unit price. That will give you the line revenue. That will give you the line revenue. I can just close the bracket and start a new line by including the additional information that I want, but it is preferable that I give it an alias. Otherwise, in my final table, when I will have all these details, I will have something that looks like that, has a header, and obviously that's not nice. So it is preferable to give an alias to that to that column here, and I will give it, for example, I will say as um, line revenue. Let's suppose I call it line revenue. By call it line revenue, I know that my table in the end will not have has header this. Though it will compute that, but it will give you a header which is line revenue. I want also the sale date, as I mentioned to you, so I put it from the sale table. Now it is from the sale table that we get the sale date, and then I want the pay method. as you see, and it is from the sale table that I want the pay method. And I also want the probably the last thing that I would want is the campus name. So I will go here and put campus name here, and I will say that it comes from another table that we call C. So that's a little bit how I'm going to design my table. That's basically what I want. I want a table that will contain 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 different columns. A big join, a join that will contain all these 10 different columns. So where do I get these different information? I will start from, it depends which one you want to use as the base table to start this from. It doesn't matter. Normally here, given that I'm starting with sales ID, I will start by sales ID, sale item table as from a table that will call sale item. And then I give it the name, the alias SI, because I'm using that up there. You remember that in the previous lecture that I gave you, when you have used an alias, you need to define it somewhere. And of course, here it's the first time I'm calling that table. That's where I'm going to define it. But then when you have started by writing your from sale item, now you need to join the different tables. You have the product tables that you need to join. You have the sale table that you need to join. And you have the campus table that you need to join to bring all of them together on a particular criteria. So from the sale item that I will have, now I will need to bring together all these different information, the product ID and so on. So what do I do now? I will bring in the product table. I'll join it on one particular criteria. So you will see that product table can be joined to the sale item table through product ID only. So what do? I say here, join, and then I will give a name of the table, which is product, and I will give it a name P. Now, by the way, when I'm writing join here, you need to understand that I'm not doing left outer join or right outer join or cross join or anything, but I'm doing basically an inner join here. By using join, you are doing an inner join because you want to bring in common um, product through these different tables together. All right. I don't want any null or anything. Now, when you join the product and you put the alias p that we are using above, then we will say on what criteria you want to bring them together. So obviously the criteria that they are going to be brought together, the only thing that is common between product and sale item, you will see here, let me just hide this and put that here. So the only thing that is common is you have sale ID, product ID, and quantity. The only thing that is common with in terms of criteria to bring them together is for the product ID. So I will bring them on product ID. But the product ID would be equal to the product ID from one table would be equal to the product ID from the other table. So the product ID from the sale item table should be equal to the product ID from the product table. That's not all, because don't forget, this I've solved the issue for these. For these, where you have sale item and even this one, it's okay. All right. I'm joining wherever there is P and SI, all these here, you will see that all these are related to the product and the sale item. That's fine. But if I want the sales date, if I want the campus name, then I need to add additional joins. But if I just wanted that, I could have erased this if I wanted and ended the whole thing here directly. It would work normally. But if I want the additional information in terms of sale date and pay method and campus name, then I need to add another join. What other join that I want to add is now for the sale date and the payment method. So I will need to get that from the sale table. Sorry. I will need to get that from the sale table. And of course, given that I'm using S here, I will use the same alias S on what criteria? What are the commonalities that you have between that sale item table, which is the base table, and the sale table. So you have here the sale table, which is sales ID, sale date, campus ID, pay method, and sale item, you have sale ID, product ID, and quantity. So the only common item on what I can join them is obviously the sale ID. So I will put the sale ID is equal to the sale ID from one table is equal to the sale ID from the other table. So from what table? From the sale item table is equal to the sale ID from the S table, that is the uh, tails table. All right, that's what we have. And then we put a final join for the case of campus. So I put here campus, and then I will say C to refer to that alias here. On what criteria? Again, the criteria would be obviously campus ID and sales ID. But there you need to be careful. You don't have sales ID on which you can relate that. Okay, sales ID doesn't have campus ID, but you know that you are bringing sale together. So if you are bringing sale together with that sales item, so you can align your campus ID with the campus ID from sale. So then I will have the sorry, the campus ID from sale equal to the campus ID from column, excuse me, from campus. Here we go. And then we end the whole thing. And this will yield a final table that will include all these 10 different columns all together and join them. Let's have a look what it gives. Here we go. You see that you have your full result as you are seeing here. By the way, if you want, you can export that. You click on export here, and then you can save it. You can save it somewhere. For example, let me just give it a name. Um, line revenue. You can save it as a CSV file, as you see here, and then I click on line revenue by clicking export and save it wherever you want. So I go on sale revenue. Just give me a second with you. So line revenue, here we go. Excuse me, not sale revenue, but line revenue. Here we are. Now you will see it a little bit better. That's basically what I obtained. Now, if I did not want these, I also could avoid. I could. Um, I may wish not to have these two columns here if you don't want the ID. If you want only the product name, the category, the quantity, the unit price, the line revenue, it's up to you. You may decide not to bring these two in the select statement so that you don't get these two columns if you want. So here we do have a combination of all these different tables in only one great and bigger table as you are seeing. So you see, for example, there is a sale ID 101 who bought USB and both notebook, and you will see that sale ID, sorry, product ID 103 is repeated 3 times here because there is a sale ID. There is a person who bought it, another person bought it, another person bought it, etc., in whatever quantity, whatever price. So you have a sales revenue as you see here. It is 450 times 2, which is equal to 900, and 20 times 10, this is our line revenue in terms of rupees or whatever it is, and you have a sale day, the cash that was, and so on and so on, right? So you see that UMD is the one bringing more revenue so far, as you are seeing here. The next step that I might be interested in would be to there. Let me just put this as it is here. We have obtained, how do we call it? Uh, line revenue. Okay, you can call it line revenue. What about if I want the revenue by campus? Let's call it revenue. But what about if I want the revenue by campus? Yeah. Let us try to understand how to get this revenue by campus now. Okay. All right. Let me just do that. Here we go. We have the campus table, the product table, the um, sales item table, and you have a sales table. All right. All of these different information you have. There are different ways of proceeding, but let's try to start from the sale item button. Is a little bit more natural in terms of explanation. So if I take that sales item table, let me just move that to this side here. If I move this to this side, so you have a sale item table. The sales item table, we can join from the sales item table, we can bring in the we can join the sales item table using the product ID with that table product ID to be able to get the unit price. All right. So to be able to get the unit price, we can bring in that. So we are basically doing a join of this table with that table based on their product ID. That's the first step. So this will give me the unit price. And from that, I can easily compute the revenue for each of these lines here, all right, for each of these. When this is done, my next step is to do what? Remember that my aim is to be able to obtain the I want to obtain the revenue by campus. All right. Now, to be able to obtain the revenue by campus, unfortunately, you don't have a campus ID that is in the product table, or you don't have a campus ID in that table itself. The only place where the campus ID is through that sales table here. And you will see that this sales table has got a sale ID that can be joined to that sale ID that you have from your sale item table. So in other words, you can join that sale item with the sale that you have here through their IDs. That sale table, in fact, will be acting like a bridge between that sale item and product with campus, because nowhere else you have campus except from the sale table. But the advantage is that you have a sale ID which also exists in the sales table as well as the sales item table. So you may join these two together by bringing in the campus details now. So using the sale ID 101, you will know that the campus is supposed to be 1. So you know that this campus is 1 1. Using the ID 102, you know that the campus ID is 2. All right. You will know that campus ID for the next one is for 103 is 3. For 104, for 103 is 3 again, and for 104 it is 1, and it goes on like that. So you are able to bring in the campus ID with that sale item and unit price and quantity together. When this is done now, when you brought this in together in that particular table, for example, from that sales ID, now you can join the campus ID with the campus name, which is our final result that we are looking for. So when you have done joined the campus name, so now you can put the campus name here where you will have North Campus, you will have North Campus again, you will have South Campus, Central Campus, and so on. Now, from that final table, I can do a group by on the campus name, and I will be done. I will get what I'm looking for. So now let us move to the SQL again. Now, to be able to do so, I will revert to what I just explained here. You will see what I just mentioned. We start from a sales item. We are going, by the way, the final result will be what? Will be just the campus name and the revenue. So you will have North Campus, South Campus, and Central Campus, and you will have their respective revenue, which will be based on the sum of the revenue that you got here by these campus that you have joined together. So let me just go back to here. So what do? We say select. We know that we want the campus name. We want the total revenue. So what do? We select c.campus, c.campus as you will see here, campus name. After the campus name, we will need the a sum of our revenue, but we'll need the sum for the revenue because just remember something is that in this example here, if you just do revenue by taking sales quantity multiplied by your unit price, you get the line revenue as we did earlier. But we don't need the line revenue, we need the total revenue by campus. So obviously that would involve adding the campus, adding the revenue by campus. All right, so you will have a revenue that you will have for the first line here for campus one, a second for campus one. You need to add these two together, for example. So that's why we need to do the sum of the quantity times unit price, just like we did earlier. And I'm going to give it the name of revenue. All right, these are the basically two information because as I just mentioned, the campus name and revenue are the only thing that we require. Then we start from, now listen to me, I've just explained it from the sales item table. That's what I explained. But you could also consider the same thing from campus, but the link is going to be the same in the end. You will get the same result if you started from campus, but the logic is a little bit different in terms if you have to explain it. Okay, but the starting from campus, starting from sales or anything will not change your answer in the end. It will be exactly the same thing. So from sale item, just like we did earlier, sale item SI, because I'm using SI here. And then you will need to join because we've got, remember that the sale item was on its own, we had to join the unit price to it. So we join the unit price just like we did through the product table. Okay, join through the product table. By the way, for the sale item, don't forget that we need, yes, for the join product, don't forget, for the join product, don't forget that we need this condition of product ID for both of them, as you are seeing here. And then we will need to join campus on campus ID, obviously, because campus is what is of relevance. It's obtained from the campus table. So we will need to do something like that. But the problem with that is that if you use campus, you have to base yourself on the campus ID to bring the campus name. Now, the campus ID exists only through the sales table, as you would have noted. So this is why we will never be able to do that unless we'll never be able to do that join as you are seeing here to get these two take columns unless you bring in that sales ID as well. Even though in the select statement you don't see the sales included, but that sale table acts as a bridge for us to be able to get what we are looking for. But obviously, it doesn't end there. Each time that you have a sum or you have an average or anything like that, you need to state that you need to use that clause that we call the group by clause. And the group by clause, obviously, it is based on campus name because you are doing a grouping by campus where the total revenue will be based on that particular campus and so on. And then you will have the order by because we want to know which revenue is higher, as I mentioned to you earlier, which one has the highest revenue. So I would want to have a campus with the highest revenue appearing first, the second after, and so on. So this is why I will need the order by close here by revenue, obviously, because it is on that column that I'm going to order my table. And when you are saying order by, it's always good to say whether you want to order in ascending order of revenue or in descending. Given that I want the highest revenue campus to appear first, obviously I will do it in descending order of revenue. So we can run this and just check if it worked as we wanted. As you will see here, you have, as you are seeing here, we have the South campus here appearing first. Sorry, we have a South campus appearing first, then you have a North campus appearing second, and the Central campus appearing third. So the campus with the highest revenue is obviously the South campus. Now let us say that I want to know which product normally drives revenue. Okay, which product drives revenue? So if I want to something like that, which product drives revenue? Basically, it's like I'm looking for the top products by revenue. If I want to do the same thing, what I will basically be doing, I just close that. So I will need the product name, obviously, and I will need the revenue as I did here. All right, so I will just copy that and just paste it down there. The only thing that I will change is obviously the campus name will be replaced by p dot product name. Let's change the product name by selecting product name here. Okay, p dot product name, and we are going to do the sum of quantity times unit price as usual to get the revenue. We'll call it revenue, and we will do the same thing from sales item as you're seeing here, and we will join here. We want p, s, I, and p. So we don't have many joins to do except only one, because it's going to be these two that we are looking for. That is, we are looking for the product name and we want the unit price, which is already from product itself, and we want the quantity, which is from the sale item table. So from the sales item table, you can join product on the same criteria that you are used to. There's no difficulty here. There's only one join that is going on. But again, you will need to do a group by, but the group by will be by what now? The group by will be by normally the product ID that you have, and it is also by product name. It depends which one you want. It is either by product name or you can group by product ID or things like that. It depends on what you want to group by. Okay, so you will do group by To be able to do the group by, I will do the group by the product name, as you see here, as I just did. And then I will order by, because I want the top three products to appear. So I will order by the revenue and in descending order as usual. If I just stop here, then I will get the not necessarily the top products, but I will get the products ordered by top revenue. Okay, order by, excuse me. I will get the products by top revenue. Here we go. You will see who hoodie, the USB drive, and the wireless mouse are all coming first. So if let's suppose I want the top three products only, I can just type limit three, uh, and that would give me only the top three products as you are seeing. Now, this is okay. Let's suppose now I want to do the daily revenue trend. So daily revenue trend. If I want to do the daily revenue trend, to know how did revenue move day by day, especially if I want to do a chart with that later on, I can export this data and then I will be able to do a chart without any problem, by the way. So how do I proceed if I want the revenue date? Bearing in mind that date is obtained from the sales column. So obviously you will need to write a select statement where you will have a sales date. You'll have a sale date. And then you will have the revenue as usual, the same thing as you have here. That doesn't change. And then from the same sale item as you see, but then you will have to join the revenue by sales. So how do I know how to go about that? Remember that sales date comes from the sale table. So obviously the alias to be used here is s.sales. I'm just using s here as an alias. So what do we want to do? We have three different tables that are of relevance here. The first one is sales item, the next one is, for example, product, and the next one is, for example, sales. So you just need to join a little bit the same thing that we did here, join product and sales, the same idea. So you just copy that and paste there. So you will join the products P on these two, join sales S, which we have just used here to extract sales data, on sales ID. And then again, if you want to obtain the sale by date, especially if you've got two different dates for a particular order or particular order, let's suppose, then you will need to do the group by and again the order by as usual. All right, the order by. But this one we have to be careful. We will not order by descending order. I will talk about that in a moment. So we group by sales data here, but I want to ensure that the data is ordered by what? It is ordered by date. All right. This is essential because if the data is not necessarily ordered by date, we might, I don't know, we might have a situation where we got the group by, but the dates are not in the appropriate order. Let's suppose I run this, and there you see that, for example, in this particular example, you see that you have the 1st of September, 2nd September, and then you have the 5th September, and then you have the 4th September. You see, there's a problem here. So what do we do to ensure that this is not a problem? We do the order by, and we put the sales date as usual. Okay, so we run that now. Normally this is supposed to solve the issue of date. Now you see that you have the first, second, third, fourth, fifth, and this is solved as an issue. So you can just export that if you want in an Excel so that you can just do a simple analysis on Excel or anything, even in R or whatever. Okay. And you can also do many other things. Okay, you can also do revenue by payment method. Let me just do that quickly. This video is also giving you a practice in terms of how you can run joins. You're getting used to the idea of join. You can do it by payment method. You can pause the video right now if you want. As you will see, you can just pause your video right now and try to do it on your own, and then you can just see what I'm giving you as a solution. So it can serve as a practice by now because you've gone through several joins so far. So you can take a pause on the video and try to do it yourself, and then from here you can check my answer. So if I want the revenue by payment method, um, what do we want to do is that I will need the payment method, which is from the sales data as usual, and I will need the revenue again. So I put it here, but the only thing is that instead of having sales date, I will have a pay method from the sales table, which is alias S again. We will repeat the same thing, of course, and you will see that there is P, the SI, and S. So we don't have this issue that we had earlier with campus. There, you can just repeat that same thing as it is. I'm not going to uh, talk about that again. So you can just repeat that from the sales item, join the product, again, sales as usual, and then we will do a group by, same thing, and we will do an order by this time, but the group by is based on s dot pay method. I could have copied that again. And the order by is not by pay method, obviously, but by revenue, to know which method is going to give you, which method is generally going to bring more revenue. Is it through card, through cash, or through online system? Generally, nowadays, you see that many people don't like to take card, they would prefer juice and so on. But sometimes we need to ask ourselves if this is convenient for clients or not. So if you want to know that, you can just order by revenue. And again, don't forget it is in descending order. We can just have a look at what it looks like. So again, you will see that the pay method, revenue, card, cash. Card comes first, then you come second cash, and then online payment. Okay. Uh, to conclude, now we conclude on the concept of join a little bit, but we move on. Again, we'll stick to join, obviously, but we'll try to move on to views now. Okay. We will save our logic, our different tables that we have obtained. We'll save some of the new tables that I'm going to write here as views now. Let us get into the concept of views that I explained to you. As you would recall, views have got a great advantage because it can be used several times without having to go through the whole uh, how do we say, without having to go through the old select statement again and again, retyping the same join forever and ever again. So let's package this into a view. You remember this one? We had the biggest table with that. We can create that in terms of a view. So I'll just copy and paste the same thing there. And then what I will do is basically to create a view and give it a name. That's all. So we are saving our select statement through a name that we will call a view. Create view, create view, and then I give it a name. For example, line revenue. Like here, it doesn't have a name as such. We are just giving it a name. We are referring to line revenue. I can call it line revenue view if you want, or I can just call it line revenue as itself. But avoid having the same name as a, a column name as far as possible. So I can call it line revenue view. And then I would do as soon as I do that, I say create view line revenue as, and then I start to write down my select statement, and then I finish with my semicolon here. That will create a view. So first of all, let me just minimize all this. You would recall that you have your campus, you have your product, you have your sale, you have your sale item. And now when I'm going to run this, I refresh here, and you will see that now a view has appeared, and that is a line revenue view. So if you want to see something from it, you can just do click on select star from the name of a view. That's all, just like you would have queried a table. That's the name of a view that you have created. So if you want, as I repeat here, you can also say select. You can write the whole thing on your own. Select star from line revenue view. That will give you the view that you are looking for. It's the same as just clicking on this icon here. So if you do that, you will get your view as you are seeing here. Now, when you've got your views as you are observing here, for example, if I want to exclude the product name, if I want only, um, let's suppose, uh, how do we say, the date and the line revenue, all right? The date and not the date and the line revenue, but let's suppose I want a particular view, column from that view. So I can choose a column that I want. So if I want, for example, sale ID, I can just type sale ID from and revenue. I will get the sale ID that I have. It will give you only the sale ID. So it all depends on what you are looking for, obviously. If I want everything, I just put the star as you are saying. You recall that earlier I wanted to obtain the campus revenue. Now you will see that from that line revenue, if I go back to this select star from uh, the view, you will see that I can easily now extract my campus name and the line revenue and do a sum of the line revenue by campus to be able to get a table that looks similar to something that I've written earlier, which is here. Where is it? The revenue by campus. Instead of writing this whole join statement again, you will see here I had to write a join statement to be able to create a table where I have the revenue by campus. So the advantage of having a whole table like that as a view is that now I don't need to go through the join again and again. I can easily just take this as a single table, overall table, and from that single table, I can derive my revenue from campus. I would get the same result that if I were to go through that procedure here. All right, instead of going through the join, rewriting the whole thing again and again, you will see that the view makes things far easier. Let me go through it and explain to you. So instead of selecting stuff from revenue line, I would prefer to have the campus name, obviously. But for that, you need to ensure that you know what are the different information that you have from the line revenue. So for example, I will need the campus name, and I will also need the line revenue. But eh, what is important is the sum for this line revenue. Okay, the sum. Now I will give it a name as, let's suppose I call the sum revenue as total revenue, or revenue by campus, whatever you want to call it, revenue. Then you will extract this information obviously from that line revenue view that you have. But then you should, because you are doing a sum here by revenue, you will need to do the group by as usual and aggregate. Group by what? You will group by the campus name, obviously, to be able to get the sum by campus. And when you can run that in only 3 lines of codes compared to rewriting the whole thing here, look at that. Um, you have 9 line of code that is comparable to what I'm doing here. Let's make it a bit more comparable. Here we go. You will see that in this line of code you'll have 9 line of code. Here you have 5, only 5 lines just to get this result compared to the above. So it makes things a bit more easy to work with. So I can just run that and you will see that I've got my same revenue before. Of course, you can order by total revenue if you want. That should give you similar result to what you had earlier. But the only thing here, the advantage is that you don't have to go through this group by again, not group by, sorry, for this join again, as you would have done through a simple select statement. So storing the name can make things far easy for you when you have stored a name of a view, especially if the view contains all the information that you require, like in the first one. Then you can manipulate that view to obtain what you are looking for without any issue. But bear in mind something, that this view that we have created is, as you would recall, I would ask you a question, you pause the video and answer the question, and then you go for it. The question that I want to ask you is that this view that I have created, is it um, this view, sorry, here we go. This view that I've created, is it an updatable view or it is non-updatable? That's the question that I want to ask you. In other words, is it a simple view or not, or a complex view? So please answer this question. I'm going to give you the answer. Just put a pause right now. Just think about it. Is it a uh, an updatable view or a non-updatable view? So the answer is, it is a non-updatable view because you have a join that is in this view, right? You have a join in this view, so it is a non-updatable view. What does it mean by a non-updatable view? I will not be able to, for example, from that view, let's suppose I do select star from the name of a view. If I do select star from the name of a view, I execute that, and let's suppose I get something like this, and I want to change. Let's suppose the unit price for ball pen is no more 20 but 30. I can't update that view at no point in time. I will be able to update that view to change that 20 to 30, for example. This is impossible. I can't do that in that view because it is non-updatable. You understand? So that's a little bit the idea of view, what it is, as I mentioned to you earlier. Let us move to subqueries now. We are going to write simple subqueries here. We've understood a little bit the concept of joins with different examples. Now we're going to write simple subqueries. We'll start by scalar subquery. We'll start by scalar subquery. I might be interested in which products are priced above the average list price, right? Which product are priced above the average list price? So how can I get that? So I need to write the select. I will say what are the product name that I have. So I'm not using the view right now, though I could use a view as well if you want. I will go directly to product name, select product name, and the unit price. The other from the same table. I'm not doing join here, making it easy, simple. So from the product table, you select these two from the product table, and you will say where you will have to select only those product whose which are priced above the average list price, above the average list price. So you will say where the unit price is greater than the average list price. So how do I get the average list price? I will get the average list price by a select statement which will return the average unit price from the product table. So that's what I did. So to obtain here, you will say select product name and unit price. That will give you two columns, one the product name, one the unit price from the table product where the unit price is above the average price. So to say, to be able to write this down, you will say where unit price is above, select average unit price from product. And then you will say order by, and then you will write down the unit price because you want to order by the unit price, and again it will be in descending order. So that will give me only the product name and the unit price which are above the average unit price. So we can just check. For example, you will see that automatically hoodie will be there, probably wireless mouse will be there. So let's check this out. So you see hoodie, wireless mouse, and USB drive will be included. These are the products which are above the unit price. Just in case, if you are asking yourself, why not do, just in case, if you are asking yourself, why not do something like that directly? All right, instead of doing this select and having this subquery. Let me just remind you something that where normally is a row by row process. It runs before you aggregate. It runs before an aggregation happens. The average unit price is an aggregate. It only exists after rows have been grouped or aggregated if you want. So in in the where clause, MySQL doesn't yet have the average. It doesn't have the average. This will occur only after having done a grouping. But this won't be, as long as you don't do a grouping, this won't work. So in MySQL doesn't have the average. You will get something like an invalid response, an error message in your output panel down there. So this is why you have to go through this select statement. It will run the select statement, get the value from that, and then it will pass it on to this where statement. So that's how you have to proceed. You don't have any other way of proceeding except through this one. There are other ways, of course, which are a little bit different, but you can do it through through a subquery as simple as it is. Now we can check a subquery. You can use it in different places. As I said, in the where, you can use a subquery using the in keyword as well. Let's call it in subquery. A For example, let me just ask you, show campuses with more than 3 sales this week. Show campuses with more than 3 sales for a week, for a particular week. Now, for that week that is discussed in the date here, for that particular week date here, you would have noticed that I'm using, sorry, you would have noticed that I'm using dates starting from 1 to 8. Please. So here, what I'm just asking you is to obtain show campuses with more than three sales, all right, in that particular data, not necessarily this week, but in that particular data. So what I will do is that I will write select because I'm interested in the campus name. So obviously, I will get it from campus name, okay, from campus, from the campus where, as I mentioned to you, I'm interested in campuses with more than three sales, with more than three sales, campuses with more than three sales in a particular week, in a given week. All right. So what I want to do now is I will say select the campus from campus where the campus ID, where this campus ID would be equal to a certain criteria. Now, but you won't be able to say equal to whenever you have multiple information that you are writing in. You will rather say use a word, you will use a keyword in rather than equal to. Campus ID equal to, you would use a key word in because you won't have only one campus ID that is necessarily going to be included, but you might have multiple campus IDs, so that's why we use in. In is a bit the same as equal, but the only difference is that instead of having a scalar value, you can have multiple values that are selected. So what are these campus ID that I want to obtain? This campus ID would be obtained from the sale table. You see, from the sale table, that's the main table that I want to look at, where the um, from the sale table you want to group by campus ID, for example. And when you group by campus ID, you will know that, for example, there is one here, two here, three here, four here. So you have four times campus ID one is appearing in that particular week. So obviously it goes beyond three. However, for campus ID 2, it happens one, two times, three times only. So it won't happen, it won't appear in my data. So what I want to do then is to come back here. I will say campus ID in, and then I will say, okay, select the campus ID, select the campus ID from now the sale table, and you will do a group by, you will do a group by campus ID. You will do a group by campus ID. So you will have here, it's like you are running a table where you have only those campus IDs from sale, doing a group by campus ID, which have where the count for all the columns, all right, with the count for all the rows rather, is greater than 3. The count for all the rows is greater than 3. But you will see that there is a small cross appearing, because whenever you are working with a group by, you cannot use this where a condition. You've been using where, you can use where wherever you want, like here you can use where as long as there is no a group by involved. Anytime you will see earlier there was where used, let me just see, in the previous example there was where used and you did not have a group by. So, but the moment that you want to do a where on a grouping where now you have campus ID sales. Remember that sales you will have campus ID repeated several times. Campus ID 1 several times repeated, campus ID 2 several times repeated, and so on. But when you're doing a group by, you will have only one campus ID 1, one campus ID 2, one campus ID 3. That's all. So, but when you are searching where campus ID 1 is greater than 3, for example, in terms of count, you can't use this clause where, you will need to use a clause called having. Having is the same as where, but on a group. That's all. Having is the same as where, but on a group where the count is greater than 3, but instead of saying where, you use having. That's all. So when you do that, we can run that particular small part here only. We select that and run and just show you what it gives us. It gives us only campus ID 1. Let's just check if this is correct or not. We go back to the sales table, and then you will see you have campus ID 1 appearing 1, 2, 3, 4 times, campus ID 2 appearing 1, 2, 3 times, which does not fit our criteria, campus ID 3 1, 2, 3 times, so they do not fit our criteria except campus ID 1. So what is happening here? You are doing a group by and you are checking return the campus ID, that is select the campus ID which satisfies that condition that the count should be greater than 3. The star that you are seeing here basically means that you count all the rows in the group. All right, in the group that is for campus ID 1, count all the rows in that particular grouping of that particular grouping of campus ID. It doesn't look at any single column. All right, it just mean rows. Count rows. That's all what you're saying. Count rows. Because there are other options that you can do. I'll leave it open to you to learn it on your own. There is the count column. There is count distinct column. Distinct column. These are what, when you do count of a column, you do a count of non-null values in that particular column. When you count distinct column, you count distinct non-null values. So it depends. There are different things. But when you're doing star, you're counting all rows in the group. That's all it says. So this is something that is interesting to do. You do it all rows in a group and you leave it as it is. Okay. So when you have obtained the campus ID in, you see the fact that we did not know if we would have more than one. By putting this in, it allows multiple values if in case there were multiple values. But in our context, there is only one that will be selected. Then when MySQL run that, it will execute it once. So it will return select campus name from campus where the campus ID is 1. So then that's why you had to write a subquery here to be able to obtain the campus ID based on the condition, and then you will get the campus name afterward. And that's what I did here. Okay. You got the North campus, which has been selected under that query, subquery. Now let us get into the concept of indexing. I can create, you would recall that normally indexes speed up reads. You can add them on column that we join, filter or even group by. And remember that PKs, that primary keys, are indexed already, and foreign key need indexes too. All right. So what we will do is we'll add a few practical ones just here. So we can create in some index. Let's suppose I create index for sale date, because I will do that later. I will make a query on sale date. That's why I want to put the index on sale date. Obviously, I give it a name. I just put it the name of ix underscore sales date. And then that index is on the sale table, its sales date, obviously. Okay, I can also create some additional indexes. Maybe I will just copy that and paste it down there because yes, I need now the sale pay method. All right, sale pay method. I will call it sale pay, and then I will change that to pay method, sale pay method from sales. And then I will repeat the same thing down there, but this time I will, let me just run this here. I want now to have the campus ID to be campus ID from sale to be indexed. So I change that. I put it as campus, for example, IX campus. So this will give useful reporting filters, and then we can obtain we can also get additional index on product ID for aggregate purposes by product if you want to aggregate by product. So I can create another index. Let me just copy that again and create index for SI this time, sales item, where I will use product ID. So I will call it SI product, SI SI product on sale item. This time it's on not on the same table that I'm going to create that. I'll create it on this different sale item, campus ID, sale item, campus ID. Okay, not campus ID, sorry, product ID rather. So we have a sale item product ID. Let us execute these. Okay, let's execute these. Verify easily if this has worked or not. For example, for sale item, you can click on this small I icon here, letter I. Click on that I. Then you will see that you have, for example, indexes, and you will see that there is IXSI product index that has been created. Obviously, the primary key is already there, so we don't need to worry about that. So you see the IXSI product has been included as an index, as you would have noted. And then if you go for the sale data and you click on I, click on indexes, you will see that there is a sale date, the payment, and the campus, which have been created, obviously. So thus knowing that you have created the index, obviously creating the index is good, but it's also good to be able to see its impact. So you won't feel it here in this tiny data set because but on normally real tables, these indexes will avoid full table scan, as I mentioned to you in a previous video. This will avoid a table scan and make things faster normally. But for the time being, let's get into an example to illustrate this idea. Okay, you have created some indexes. Let me use one of them. I will show you how index impact with the date filter. Um, Let me, for example, I want to select the sale date and the sum of quantity times price. sum of quantity times price, and I will give it the name as revenue. From, I will just repeat basically the same kind of situation here. Where is it? From sale item, join product on and sales the same. I will just copy these two because you have only sale date, which it comes from the table sales. All right, you would have noted here, and then you will have SI and you would have P. So you have S, SI, and P included here. Now we'll say where the sales date is between, let's suppose, to be able to understand that better, let's go on sales. Let's suppose I want it to be in between the 1st September to the 5th September. All right, the 1st to the 5th September. So you have 7 days here, 1st to the 5th September. 7 records for that. Where sales date is between, remember how it is written. Let's go back to that. So the way it is written is important. We need to write the same way. So you will say between, but the fact that it is a date, it's good that you put it in between inverted comma here. 2025 2025 bar 09 bar 01, sorry, and when I do that, normally this between is an inclusive in between, don't forget that. 0905. As usual, the fact that we are doing a sum up there, we need to do a group by, and we need to do group by obviously date, because that's the way the data is going to be presented. And we need also to do an order by, remember, by date. So that's what I have here. But when I'm running that, you won't see much of a difference. You can run it if you want. There will be not much of a difference. You'll just see the result as it is. But the advantage of doing that, of running this on an index, which is here in our context sales date, for example, the where is based on a sales date. All right. The advantage is that if you write down explain, that is to see your query plan, by writing explain just before select, that's all you have to do, nothing more, nothing less. Just write explain and then select. You run that, you will see that now you get a series of information. By writing down the explain, select, you get a series of information. What would be of relevance to us will be the type, would be the key, and would be the number of rows that has been taken into account, and so on. Let me discuss that quickly with you now. What you want to check here is mainly this column of type, sorry, mainly this column of type and the rows table, and also just to have a look at the let me just run that again so that I can leave it as it is. You want to check that column of type, you want to check the extra, and you want to check the rows as well as the key, obviously, which is important. If this was null, that would have been a problem here. But the type is interesting. So whenever you have a range that is used, that means that the index, there is an index range scan. Like, why is this so? Because we add a between here. That's why you get the type as from the sales table. You will see that from sales date, you have done a between. That's why you've got a range table. And then you will have ref, which is an index lookup by value. So the ref is an index lookup by value. It indicates obviously that there is an index that is being used. That's already one thing. The QF here uh, means that from the previous table, that is, we had the SI. If you look at it in the order that is presented as it is here, you have the first table that is read is sales, second is sales item, and the third is product. Now, in the product, that is for each item line that you add in the sales item, when you have this EQF, it means that it does an exact primary key lookup on product. Normally, this is the best join type that you can have. It's a good thing that you would like to have. So as long as it is range, as long as it is ref, as long as it is EQ ref, that's fine. Okay. Normally, these different types, what you need to know, I'm not going to get into the details of all these right now, but you just need to bear in mind that whenever something is range, something is ref, something is EQ ref, you can go and investigate it further if you want later, okay? But whenever you got something like these, it means that these are good, we can say plan signals if you want. They are good plan signals. But when you get things like all, it is a bad one. Why? It is a bad one because it involves a full table scan. Whenever you have this all that is used, it means that it is a full table scan, and this is not what you want. But if you get things like range, ref, EQ ref, that sounds good normally. Okay. Uh, then the other thing that you will see is the possible keys that are used. You will see that the indexes are being used here. You have the IX sales date, you have the product IDX, product ID, you have the ID sales item product. All these are the different uh, product of a different possible keys that are used, where the index is also involved, where the product IDs have been also converted into an index, as you are seeing. And then what you will see also is the key. Obviously, the key is important, but the key mentions here that you are using an index for the sales table, and that index is sales date, which is obviously good thing, implying that your reading will be going faster if you had this table was relatively huge, for example. You would recall that in our sales table, you had about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 sales ID, but you will see that the number of rows that have been scanned is not 10, but it is 7 that have been scanned just because of a range. So the range is on sales date, and sales date is an index. So, in other words, only 7 rows have been scanned instead of going for all the rest. And then for the other keys, there's only 1 row that is scanned directly from the primary key that fits the requirement that we have here. So what is happening here is that the plan is a 7 by 1 by 1 index lookup if you want. And we can say that this is an efficient one. It's an efficient one just because we are using an index. We know that things are going relatively fast and so on. We know that we don't have to go through all the 10 table. We know that this is not all. We know that this is not the full 10. We know that this is not null. As long as this is not null, it means that an index is used and it is an efficient reading that is going on. Uh, so that's about the explain, that's about the query plan based on an index. Now that you have understood a little bit the principle of joins that I've explained to you, you have also understood in earlier how I don't have it here on that script, but earlier how to create your foreign keys, how to create the. By the way, you can click here to see the indexes that are used, campus name, and so on. So you will see that you have seen how to create your foreign keys, how to link different tables together. You have been able to do joins and so on. You have been able to create a view. And in addition to that, we've gone through the subquery as I explained to you in previous video. Just briefly went through the index and also gave you a brief idea of the query plan. The query plan is just a simple thing, just telling you whether an index is used and whether how many rows are being selected, whether the code is being run efficiently or not. Whenever you have a all here as type, it's not good. Anything like range or ref or eqref are things that indicate that that indicates that you are doing an efficient query rather than querying everything in the database, every row in the database, rather than doing a full table scan. So you are not doing a full table scan when you see things like that. And you can see what are the keys that are in use, what are the index that are used, and you get some additional information here, and you know how many rows are there. These are the kind of things. By the way, if you write analyze here, I'm not going to do that with you, but I'm just mentioning it. If you write analyze here, you will get even cost in terms of the timing used as well. But this is outside the scope of this course. I'm just mentioning it here for your knowledge. So what's our next step now? We will go and do some application in R based on what we have obtained here. We are going to do some applications in R and also do some visualizations, basic visualizations on our result that we have obtained. Now, what I'm going to talk about is about a package called dbplyr. Okay, and what I will do with you now is to I want you to see the same relational thinking that we have been using in SQL with regards to the previous part of the video today, and we all these will be expressed in R. So what we will do is that we will use this dbplyr package. Now this dbplyr package, normally what I will be doing is that when I'm going to run when I'm going to use dbplyr, what I will be doing is that I will be using dplyr verbs. We can call it like that, dplyr verbs that you have already seen in a previous video where I've been introducing that very briefly. And what happened is that dbplyr will translate these db these will translate these dplyr verbs in into SQL, into structured query languages. And what it will do, it will run in a tiny, I can call it like that, it will run in a tiny, with let's just say in memory SQL SQLite database. What do I mean by that? It will run a tiny in-memory SQLite database That means it won't be using the SQL community server, the server that we used in when we were opening MySQL. When we were opening MySQL, the server stored all your data and so on. But here we will have a small, tiny in memory that will be saved on your RAM. Basically, that's the idea. It will be saving your database on your RAM, nothing more. What does this mean? With dbplyr, there is no server setup to do. You see, when you were running MySQL earlier, when you were running MySQL Workbench and you had to install all these, you would recall that you had to do some setup. Like you had to install the MySQL community server and so on, and you had to include password, etc. But here with dbplyr, I will not need to do all these. I will not be using any password, no server setup. We can just um, if you want to see the SQL queries, remember that we are not going to use SQL language in dbplyr to write something. No, we will still be using dplyr verbs. We will be still using the words, the keywords that exist under that function and under that package. That is, we will be using these different functions under that package, but we will not necessarily use SQL. But what will happen in the background is that dbplyr will normally take these dplyr verbs that you are writing, these dplyr, let's call it words instead. If you don't understand the word verbs here, it's just the dplyr functions and all these different things that you are going to write. It will translate that into SQL language. Okay, now when it does that, if you want to see, if for example you want to see what is going in the background when you are writing your dplyr and how it translated into SQL, you can do show, for example, query. When you do show query, it will give you that same dplyr verb that you have written, how it translates into SQL. Uh, that's a little bit what we are going to do. We'll compute in the database and only collect small summaries to plot. That's what I will do. We will use mainly, you will see, you would recall earlier that I was using, let me just open this for you. Just give me a second. You would recall I have loaded this data earlier, and we will be using that. Just give me a second with you. This is the data that I'm going to use, and we'll be using that data. Now, um, what we will be doing is that not next week, but in one of the forthcoming lectures that we are going to go through, you will use something that we call DBI, that will be that will allow you to connect your database from MySQL to R. But for the time being, I'm not doing that. We are not setting up anything. We are not setting up any database or anything like that. We are just running dplyr codes, dplyr verbs if you want, or codes that will translate in MySQL that you won't even necessarily see unless you put things like show query and so on, just to have an idea. So basically, we are kind of doing a sort of light version of a database that is stored in your RAM memory. And the moment that you close out, that database that you are working on will disappear automatically. It will not be anymore in next time you can't open it and you will get it back. Compared to a MySQL, when you come, open, you close, you open it again, you will see that you will have your database already available on there, unless you have dropped the database and deleted it. So that's the idea here, is that we are mimicking, not mimicking, but we are doing a sort of light version of a database that will be stored in the RAM and will disappear as soon as you close R. Just bear that in mind. It's not going to be saved forever here. It will be stored for a moment, and then it will be the moment that you close R, it disappears. Okay. What are we going to do now? We are going to start loading the packages and read the CSV that I just showed you. We are going to do that, and we are going to run some codes and see how to use dbplyr. Remember that our aim here is to talk about dbplyr. To start with, let us load our different libraries, our different packages. So we will start by the first package that we will refer to as library read R. What is this library read R? You will see that I'm going to use that at some point in time to apply the function read CSV. All right, there is a function called read CSV that allows me to read my file. Then I will load another library called dplyr, obviously, which is going to be for our verbs that we mentioned earlier. That will enable me to do group by statement. That will enable me to do summarization. That will enable me to do arrange. That will enable me to do things like mutate, filter, and many other things that exist. Okay. All these are different reasons why I might want to load this library so that I can do different applications like group by, summarize, arrange, and so on and so on. Then I will also obviously download the dbplyr, which is our database backed table. I explained to you what a table was. It's a little bit a modern version of a data frame, as I mentioned to you in a previous video. So it will enable us to get a database back table, plus do some SQL translation. Not some, but we'll do SQL translation. And we can also run our show query that I mentioned to you to see what are the queries running in the background. Uh, if you want to see that, you can run the show query. All this will be available from the dbplyr. So it's a database back table. So it considers our data frame through a database that is stored in the RAM, as I mentioned to you, and there is no connection, etc. So then you will also, to do some visualization, we will use a very well-known package for plotting. That would be visualization. That would be for the visualization. These are the um, different packages that we will require to work with. Now, that's good. The next step is also to load our file. Now, to load our file, we will need to use that function read CSV, as I mentioned to you. Now, to load the file, we will need to use that function CSV, but I will give it a name. I will call it line data frame. Line data frame, because it's a line revenue that I'm going to load. As you would recall, here is a line revenue that I need to load, and it is called line revenue.csv. So I need to locate that path and read it in the file. So because there are quite a number of things that I'm going to include, I will start by the first thing, state where the file is, and that's the way that you write this. You put down the path of a file. How do I get the path of the file? I will need to go in my lecture 6, as you will see here. And I need to locate the line revenue folder, that you have saved in the beginning of the video, rather in the middle of the video. You will see that you need to copy, right click on it, and you copy as path. You copy as path. That gives you the path of your file where it is located. Right click and copy as path. I'm using Windows version here. So for those who are using Mac, you might have to adapt. Uh, but at least you get the idea of what I need to do. So that's what I do, is that I copy the path. All right. You don't need to put it in between inverted comma again, because it will automatically put it in inverted comma. So you put the path. There is only one code that I'm writing here, and the whole path. But the only thing that you need to do in R is that you need to do an additional thing, is that you need to replace all these backward slash by forward slash. So you do Control H, Control plus H on your keypad. You do Control H, and then you replace all the backward by the forward slash, and you replace all. That automatically changes backward to forward slash. So that's the first step in reading the file. I'm not yet over. When you have given the file name, as you have seen here, the path, you need to put a comma here, because we will continue with something else. What are we going to do now? It's very good that you state what your columns are. All right, I'm going to explicitly mention the column types, so that dates are considered dates and numbers are considered numeric or integer, but nothing else. For example, I don't want date to be considered as a character or anything when I'm loading that data, you see, because when I will read this, it may take this as a character. For example, just to avoid any issue, to avoid any problem, I will explicitly mention the different data types for each of these. Let us start the conversion. To convert, we are going to write col underscore types equal to, we are going to say, okay, convert the different columns that will include number one, sale ID. As you would recall, let me just come here. We'll have product ID. You can copy that if you want. Let me just copy and try to paste that there. Make things easier. We'll have all these product ID. We'll have product name, category, quantity, unit price, line revenue, sale date, pay method, and campus name. These are the different different not characters, but different column names that you have for that particular case. Okay, now the next step is to say, okay, we have all these different columns and we want to give it a name. Maybe I will just put the equal here just to make things a little bit easier. Each of these will be equal to a certain data type. Now, sale ID, for example, maybe it is already stored in integer. We don't need to worry about that, maybe. But here I'm explicitly, as I said to you, deciding to convert them into specific data types, just in case if they are wrongly read for some reason, they are misinterpreted, for example. In the context of sale ID, we'll keep it as integer. Normally the sales ID, as you will see here, it is supposed to be integer. So we'll keep it as integer. How do we do that? We say column underscore integer. When I do that, it means that I'm converting sales ID to integer in case if it is not saved as integer. The same will apply to product ID, obviously. For product name, however, you will see that here, product name, if you do a filter, technically speaking, there are only one, two, three, four, five, and six. If you want, maybe conceptually, these could be considered as categorical data. Okay, these could be considered as categorical data, but uh, When it comes to dbplyr, it is better to keep it as a character. It is better to keep it as a character because normally SQL don't have an R factor type. All right, doesn't have an R factor type. Factors are basically just stored as a text in SQL anyway. If you want to consider, for example, these in SQL, if you were to consider them, they will be considered as text. They would not be considered as factors. Though conceptually they are factors, factors means categorical in nature, but they will be considered just like text. So we will not worry too much about that. We will keep them as a text because when you are going to do the group by and you're going to do the summarize a function, you're going to apply the group by that I explained to you later. Let me just open that for you. If you're going to do the group by, you are going to do the summarize functions, all these, they will behave the same for character, just like they would have behaved for factor on a database side if ever you have a possibility of including a factor. But factor is not something that you necessarily need to include here. If you pass these as a factor at the read time, it can cause some headache later because some unseen categories may become NA and it becomes an issue that you don't want to get into. So you can keep it as it is, just a little bit like what it would have been in the SQL. When you would have considered that not as factor, you would have considered it as a text. So let's leave it as a text. We won't change that. Okay. Bear in mind that when you are going to, if you want to convert to factor, you can do so at the collect time later. But right now, there's no need. We will keep it as it is, as text in other words. So let's continue with that and we include them as text. So to do that, we do call, and then we do underscore, and then we do character. By doing that, I am keeping it as a text, and obviously category as well will be a character, isn't it? Category will be character. So then you have again integer that comes for quantity. But the unit price, you have the possibility of including double, as in fact we mentioned in our database earlier. So we'll keep it as double because it allows the possibility of having decimal places included. We have a line revenue that will be also considered as double because there's a possibility of having decimal places. Then the sales date, I'll come to that in a moment. Let's just put the pay method and the campus name. You would recall pay method and campus name. Again, they are text as you see. So we go back and we put these as character again. Here we go. For the last one, there is no comma because it ends there. But for sales date, what do? You do date, call date as a function that will enable us to convert our sales date to date in case if it is considered as character when you're loading it, just to avoid the issue. But it's good also to mention what format that the date will be, because there are different formats that date can be. For example, in our case here, let's move on. If we take here, you will see that our format is like you have normally 9 1 and 2025. You have it in terms of the month, the day, and the year. So how can I uh, include that in R? If it is like this in R, I can decide to change it if I want. I can pass it to whatever, uh, how do we say, whatever format that I may want. I can keep it the same format as it is. In other words, I keep it as um, month, day, and year. But you can also use the isodate format. There's something that we call the isodate format. You can also include isodate format, which means that it will be in form of year, month, and day. You can include it as year, month, and day. To write this down, the isodate format, there is a way I'm going to write it down. I will say, I'm not going to write it as it is here, I'm just mentioning it. So we will put it in between inverted comma, and then we will put the format by taking the percentage sign y. Here we put the percentage sign m, and we put it that way, and then we will put $D. Now you see, I'm just mentioning it here. If you want to know a little bit more about date format, you can just go on Google and just study a little bit about the call date for. You can go and search for call date function from the call date function from the read underscore CSV function to be able to better understand what are the different formats. This is one way of writing full year, a full month, and full day. Okay, what will happen by doing that? It will when I'm writing this uh, percentage sign, I expect to get something like 2025 bar. When I put that bar here, I expect to get something like 09 bar 01, for example. That's what it's going to give me. When I do this, when I write it like this, percentage y, percentage m, percentage d with the hyphen in between, I expect to get something that looks like this when I'm writing that. You might wish to choose another date format if you want, but here what happened is that R will convert that date format, because here it's different. Here you see that the date format is month, day, and year, but here I decided to change it to year, month, and day, which is what we refer to as the isodate format. The isodate format means you will have the year, then the month, then the day represented. So you have different way of representing date formats. You can go and investigate further if you want. Okay, but for the time being, what I'm going to do, I will leave it as it is here. Then you have color character. All these are what we want to do to read that file. So just remember, to read that file that I have here, I will pass on these different characters, integers, and double and date format to them, just to ensure that there is no problem later if in case. Normally R is sufficiently smart to detect what you have based on this read underscore CSV function. Sufficiently smart, but still, it's always a good practice just to mention your data types. So what I will do, I will run that. So we have got an error. Just hold on a minute. So I think I forgot to load the library. Sorry. Here we go. Let's load the library and run that again. For those different libraries, by the way, if in case you did not have them installed, don't forget you need to do an installed packages, and then you put between inverted comma ggplot2. Remember that. If in case this is not installed on your laptop, you will need to do these different things. For me, given that I already have them installed, I don't need to do them. I don't need to do this installed packages. But for you, don't forget the inverted comma, please. When you are running these libraries for the first time, for example, dplyr is something that you already have because you've done that in the previous video. But you don't need to do that for dplyr. But for dbplyr, you did not do it yet, so you might have to do that. You see, you might have to do installed packages before you run that. So just for information, okay? Just bear that in mind. So now that I've run, it's always good to, when you open your bracket, you close the bracket immediately, just so you see that you don't do any mistake and you forgot any brackets in any case. Let's continue. Then we can have a look at the view, the line underscore. Remember something, that this um, line df is normally a data frame. Okay, it's a data frame, but a modern data frame that will be called a table, and this table will include in the columns the data type as well. It's a modern version. Sorry, let me run that library. Yes, I did not run this. Let me run this. Very good. You can view the data frame in the form of um, a spreadsheet, as you see. And if you type line df, or if you want to see only the few, if you want to type line df, for example, without viewing it in the spreadsheet format, you can just type line df and you will see that this is a table, as it mentions, a modern version of a data frame with 16 rows and 10 columns. So you will see that the data types are also mentioned under the names of the columns, as you are seeing. And you will see here, look at that, it is 2025 0901, just like I explained to you earlier when I want to convert that to ISO date format. If it's always a good idea, if ever there are different date format, if you want, you can convert to ISO format. That's a well-known and accepted date version, and you can use that. Okay, so that's how you are going to read your data, your data in R. You can already see the data in R. Now, what we want to do is to create an in-memory database table. We want to create an in-memory database table. To be able to do that, we'll need to use the function memdb underscore frame. memdb underscore frame, that would be the function that will enable me to create that database table in the memory, in the RAM. Remember that this comes from dbplyr. All right, the memdb will enable me to create that table and put it in the RAM. Of course, when you're going to close your R, open it, it will be disappearing automatically. You'll have to run it again to be able to get it, not like, as I explained earlier, for MySQL. So what you are doing is that you are copying data into a tiny SQLite database that is going to live in the memory. Now, the memdb frame, you are going to say, okay, we are going to create that table in memory, that table that we have created here, the table here, basically that table, that full table. We are going to create it and put it in the memory. And obviously, we will call it something. We will just say line underscore tbl, line table. Okay, let's call it line table. And then I run that. And let me just run that. And when I run that, if you want, you can type line table. There will not be much appearing, except that now you will see something. You will see that the source, the table is named something like that, uh, and it is said dbplyr. It is no more considered as a table as we have seen earlier. It is referred to as a database. As you can see, it's an SQLite. It is in the memory, and that is what has happened. Compare this to what we had earlier. In line df, you had a table of 16 with the database, with the columns and their data types, but here you will see that it is now considered as a database, as you are seeing. And it has got a very strange name, as you see, because it is a name that has been attributed to it automatically. Now, when you type line tbl, you saw what happened. By the way, if you want to know what this is about, when you type the line tbl, basically you've been able to view all the columns that you add in your database. So if you want to know what is happening under the hood to be able to see what is the SQL query, you just type show query and then line tbl. So you will see that this code has nothing to do with SQL. It's just a function that you are using from the dbplyr. It's a function that you are using, but you will see that, sorry, excuse me, this is translating to SQL. So you know that code. You see that in the background, what is going on is that it is running the select stuff from dplyr database. As you see here, the database table, the table that is named is called dbplyr. It's just a name that R has given. For us, we know that it is a line revenue. We are going to change that in a moment anyway. So we want to change that table name, but for your information, it is just selecting stuff from a particular table. That's all it is doing in the background. Why is it doing so? Because we have converted it into a SQLite database, which lives in the memory. Now, the next step is that you see that name is not very nice to work with. Maybe I will change that. And if you want to change that name, I will override the current line TBL with a different this line table. I will override it by changing the name. To do that, I will use a function compute. That function compute, what it will do, it will materialize and name the table inside the in-memory database. That's what it will do. So what is the compute? It computes line tbl, and then you say name equal. Um, in that compute function, you are able to change the name and then you call it line revenue, for example, and that would be referred to as line revenue table. And then you run that. There's nothing much that will happen. If you run the line TBL now, you will see that the name has changed to line revenue, and it is not that strange name that you got earlier. So if you want to see the show query again, you can run the show query again, and you will see that now it is running it from line revenue table, as you are seeing, and it is a backtick as well, which is something that is quite common in SQL. You would recall earlier in our database, we have been running revenue by campus. You would recall that at some point in time we did that particular exercise. This is our line revenue that we had, and we had also done something like that where you obtain the revenue by campus. You had to do a group by and an order by. Of course, you had to do some joins and so on here in the background. So what are we going to do now? We want to reproduce the same kind of thing where you have a total revenue by campus, and we can do that here in R. So what are we going to do? We are doing revenue by campus. What it will do is that it will be mirroring a little bit your SQL group by campus that I just showed you here earlier. I just showed you there. We're going to reproduce a little bit the same thing. Revenue by campus. So how are we going to do the revenue by campus? We are going to say, let me just first of all give it a name. I call it revenue underscore campus underscore query. And then I will say line TBL. I will use a pipe operator. As you would recall in my previous video, in one of my previous videos, I've mentioned that the pipe operator. The pipe notation here is being used to say, okay, from the line table, then group by. You want to do group by. This is a verb that, as I mentioned to you, that exists under dplyr. The pipe operator is also under the dplyr package. So you are doing the group by, you're going to do the summarize in a moment, and you're also going to do the arrange because I want to order the data. These are the three things that I want to use for the time being in terms of verbs, okay? In terms of the verbs of dplyr. So we'll start by the group by. Number one, you need to group by campus name. Put the name as it is here. Where's the campus name? Let's find it out. I didn't give us the whole thing from the database, presented only a few. Two more variables, pay method and campus name. It did not show it, but here we go. The name is here. We're going to copy that campus name. And then when we have grouped the let's put it down there so that we can read for readability purpose. Let's put it down there. So you do the group by, okay, and then when you have done the group by, we will pass on something else now. We will pass on something else. We have grouped. If we just group, that won't bring much information unless you decide to do a sum. Because when you talk about group, it's good. What do you want to do with the group? Or you want to do an average? Do you want to do a sum? What do you want to do? For example, let's suppose I want to do a sum. To be able to do that, I will need to use this function summarize, which is a function that exists in dplyr. Again, if you are looking at that, it's the first time that you are seeing that, and it's something new that you are learning, obviously. So you just need to get used to these different functions that I'm mentioning. They are useful if ever you are using dplyr and you want to repeat a little bit the same thing that you have learned in SQL. We will summarize the revenue, which is going to be equal to sum of line revenue. This is what we want to do. We want to do a summary where it sums the line revenue. I'm going to call it revenue. And again, it's not over yet because I've got an additional thing. If you recall clearly here, there were, first of all, the group by, and there was a sum that was going through it, and we call it revenue. And the group by is okay, but we also did an order by, and the order by, the word that we will use in MySQL would be not MySQL, but the word that we will be using in dbplyr would be, first of all, let me just copy that pipe operator here and just put this here. And then we will do again the arrange, as I explained to you earlier. We'll do the arrange function, and the arrange function will be ordering the revenue that you have created here. You will order the group by the summary that you have obtained in terms of revenue by campus. You will group this revenue that you have created. We'll give it a name here. This revenue is a name that is the sum of line revenue, which is a column basically that you are defining. And don't forget that when you arrange the revenue, you need to state whether you are doing it in terms of descending or ascending. You would see that we have done it in descending. So the way you write it down here is you write DE, DES, and then you put revenue, as you see here. So that's one thing that we can do. And run that. Here we go. So you can just run that if you want, and you will see that it gives you the South Campus 4,800, the North Campus 8,690, the Central Campus, it's doing the same thing. By the way, in terms of missing values, just for information here, we don't have an issue as such, but if ever there are some missing values in your data, it's always good to put here an a.rm equal to true. Okay, and a.rm is equal to true. If ever you find that there are missing values that may exist in the data, you may do that. But in our context, it's just a warning message, but it doesn't matter much because there was no missing values. So this is why I did not write it, because by default it is false in any case. So you've seen that you've got your campus revenue just like you had before, 4,800 North South Campus, etc. You got exactly the same result, but in a SQLite version which exists in the memory, as I mentioned to you earlier. So by the way, if you want to see the query, you can also show the query from that. You can write show query, then you can write show query like that, show query, and then put this revenue campus query in there. Or you could also use a pipe operator, as I mentioned to you, which is just passing on a function which is called show query. If in case you did not understand the principle of piping by now, you would understand that when I wrote something like that, it means that I'm running that function show query based on what I have here. I have my revenue campus query, which I just showed you the data that I've got, and then I want to show the query to know what is going on under the hood behind. So let me just run that. Here we go. So you can see clearly that this is very similar to what we had here. The only difference is that we won't have a join. Why? Because we are using the line revenue directly. There is no join where the line revenue uh, that we have created, the table that we obtained from this. You remember that we exported that table as line revenue as I showed you. And that table contains all the information in a single table. That's why you don't need to go through the join process again. But apart from the join process that you are seeing here, you can just quickly have a look. Let me just open you will see that just let me just minimize that and then show you to you here. So you will see that there is a sorry, the result. I need to see the result. Here we go. You will see that there is the select campus name. Obviously we won't have c.campus because there is no alias or anything to use because it's a single table that we are using here. You have some line revenue as revenue. You can see clearly that's the same thing. Again, you don't need to have as quantity times unit price. This has already been done and has been named revenue, and for us in our table it is called line revenue. So and we refer to it as revenue just like here. And then you will see that there is a from, but here we don't have sales item join and everything because it's a single table which we have contains all the information that we obtained earlier from that table. So this is why you don't get the group by and everything, but the rest stays the same. Group by campus name, group by sorry, I'm doing something, here we go. Group by campus name and order by revenue, as you are seeing this DCS. So you see clearly that when you have run, let me just show you that. So you see clearly that when you have run that dbplyr, in fact, this dbplyr package is converting whatever dplyr verbs that you have written in database in SQL language in the background and giving you the result that you are seeing here. It is translating what you have in the background. You don't necessarily need to see what's going on, but it is doing it in the background, translating the whole thing into SQL and providing you the result that you are looking for. Now, remember that uh, this is an in-memory and a simple version of how you can run a database in R. You can run a database in R in memory. That is a simple thing that you do. In the in about 2 weeks' time, I will go through how you connect to. In about 2 or 3 weeks' time, I will show you how to connect your real database with R. That is going to be a bit different. Don't want the this messy result with all these details. You just want basically um, something that runs in R, for example. That is, if you want to bring that result back to R, it will now be called a table. It won't be a database anymore. If you want to bring that into an R object, and right now it is not an R object, it is a database. Now it is a table from a database, but if you want to bring it back to R, uh, you run it in the database and bring that small result back in R so that you can run your graph, for example. You can run a simple graph that I'm going to show you in a moment. That's what you can do. You come here and you remember you have a revenue query that you have run here. You will use the pipe operator as usual, and then you will say collect. When you're doing that, what you're basically doing is that you are taking that result that you got from the database and collecting that result and bringing it into R. R will take that data and convert it. Obviously, it's not going to be any more database, but it's going to be a table now. It's going to be a table. So what we do is just give it a name. Let's call it Rev Campus. I call it Rev Campus, and then I run that. Let's run this code here, and then sorry, let me just run that code here. Where we go. And then if you type rev campus, you will see that there is a small change here. It is no more in that structure that you had earlier, which is the source SQL, database, SQLite, memory, or whatever. Now it is saved as an R object, which is referred to as a table. And I explained to you what a table is in a previous video, as I mentioned to you in one of the previous videos. So that's what we have as a table. Without much further ado, let's get into the concept of ggplot, that is the package ggplot2 that I have installed here. This package will enable me to draw uh, graphics that are excellent as far as possible, all right, compared to the base R graphics that we have. It gives you many advantages. In fact, the ggplot, it has three main parts. It will have a data table that you need to give to it. You will need to give a ggplot the mappings from columns of your table or your data frame, whatever it is, to the axes. And this is done through something that we call aesthetic. And I will explain that in a moment. And then everything comes in layer. Then you add drawing layers one by one. So there are three parts: the data table, the mappings from the column to axis, and then you start by giving layers. You start to add on to these information. That's basically the idea of ggplot. So now what we are going to do is visualize the rev campus data. Of course, I guess you would have understood that if I want to visualize this campus data, this would be done through a bar chart. That's the best thing to do. So what are we going to do? We are going to draw that bar chart now. So don't forget, we will need the data table. We will need the columns that are going to be mapped to the different axes, whether you have X and Y. This is called aesthetic. And we will need to add a layer that decides how to draw it, whether you want to draw a bar chart, you want to draw a line chart, points, or whatever you want to do. In fact, in ggplot, sorry, everything is a layer we can add. We can add a title as a layer. We can add uh, a theme is another. A theme is another one. I will explain to you what a theme is about later. So everything is normally a layer. So let us start by writing our drawing our graph. We'll start by the function ggplot. That is the function that exists under that package ggplot2. If you did not install that package, that would not work. So you need that function ggplot2 from that package ggplot. So we need to run that function ggplot from that package called ggplot2. Okay, and that package, we will start by mentioning what is our data, as I mentioned to you. What is our data table? Our data table is the revenue campus that we have converted to a table through the collect function here. Remember that you have to convert it to R, an R object, to be able to draw it. You can't draw it from that query directly because it is from a database. R will not be able to read that normally. So you will need to run it through that table that you have created through that collect function. And then the second step is to do the mapping of the columns to the axes. The mapping of the column to the axis, which columns control which visual parts. That's what we want to do. So we will normally have a horizontal axis, which will be X, and we will have a vertical axis, which will be Y. And we will need to mention, so we will put a comma here, and then we will put AES, which is our aesthetic, and the aesthetic controls the column mapping, as I mentioned to you. So you'll need to say what X is equal to and what Y equal to. That's very important. what y equal to, what x equal to. And our table, our x would be normally in a bar chart. If you want a vertical bar chart, you will have your x representing your campus name. And in our example here, the y would be revenue, as you see here, revenue down there. This is our table that we are using, and this is what we expect to have. So if you just run that thing here for a moment, just run that, you will see that you will get something like a blank, not, you will get something like this. Okay, let me just run that. For the time being, you will get something that looks like this. Okay, a blank graph with campus name with the different labels from from the campus, and you will have a revenue on the vertical. Generally, in a bar chart, you will usually have, how do we say, the counts, but here we are not going to use a count. I will explain to you how in a moment. So we've gone through the first two parts, which is by mentioning what is a data table and what is the mappings from the column, what would be on the horizontal, what would be on the vertical. So you'll know that we will have a set of bars that would be appearing here. Okay, the next step is to add a layer. As I mentioned to you, draw in layers when you work with ggplot. So what do you do then? You will need to do plus. Each time you have to add a layer, you do plus, and this plus you would state each, as I mentioned to you, everything is a theme in everything is a, not a theme but a layer in ggplot. For example, here, the next step is to state what, how should we draw that diagram that we have here. Should we draw it like a bar, a line chart, a point? What are we going to draw? So that's what I add, the additional layer. And this additional layer, I state that I want to draw a bar chart, and that bar chart will be written through that function geomcol, and then we'll add another layer. I will talk about that in a moment. Let's just erase that for a moment. When you say geomcol, now generally we don't use general geocom call to be able to draw a bar chart. Generally we draw geombar. It's a function in ggplot that enables us to draw a bar chart, but the issue is that when you are drawing a bar chart using geombar, it will just count how many central campus you have, how many north campus you have, and how many south campus you have, and then draw a bar chart with respect to the counts. This is why I'm not using that function gembar, but I'm using the function gemcol, which allows me to take a vertical axis as revenue to be plotted instead of counts. Okay, that's the advantage. So with gemcol, what it does is that it draws bars with given y and not the counts. It draws the bars with the given y and not the counts. So if you run that, just run this like this, you will see we'll need to run everything together. And we can't run one by one. Let's run this together. And then you will see that now you get your graphic. So you see how easy it is here to draw this using ggplot. It is relatively simple. You just need to get used to the language. Obviously, it's not something you are used to, but it's not that complicated. So you start with the data table, you put the aesthetic, what you put in X, what you put in Y, and when you've done that, you put the geom call. Now, of course, there are some improvements that I can bring to that. For example, I want to bring a title to that. I want to remove that campus name because there is already Central Campus, North Campus, and South Campus, which is quite clear. There's no need for me to have this campus name. And I want also to state, rather than revenue here, I want, because in the vertical, I will already mention that it is revenue by campus. So instead of revenue, I want to put the scale, which is the Mauritian rupee, for example. And at another point in time, I want to remove that background, which is gray, which is not very nice. So let's start by the first step. So I do add another layer to that point, to that graph, where the layer will change the different labels. So you have the different labels and the theme, the different labels rather. So you want to add a title, you want to change the axis label, etc. So let's do that. We'll do that through that function labs. Of course, it requires getting used to these functions. If the first time you are seeing it, it's something new that you are learning. But if you were to use it for an assignment or anything like that on your own, you would have had to discover things on your own to see what are the different things that ggplot can do. How can I improve a plot? How can I add other things to a plot that maybe was not taught to you? You can do that, and you go on Google and just study and learn new things on your own if you want. But here are certain things that I'm explaining to you right now. So then you have a labs, and then you will need to put, let's suppose, a title here. In base R graphic, you usually use the word main as an argument to a function. But here under labs function, you will say title equal, and always, because it is a text, you put in between inverted comma, you say revenue by campus. Revenue by campus. Let's suppose I put revenue by campus. Okay, that will give me the title. But if I just run that, let's see, you will see that the title revenue by campus has appeared here. And then if I want to change that and remove that campus name, I can do x equal to null. The moment that you put x equal to null, x refers to the labels, obviously. So x equal to null, so remove that campus name here. So let's run the whole thing together again. You see that the campus name that was here disappeared. And then you have another one, which is y. I want to change this to MUR. So we use Y to stand for the vertical axis, and we replace revenue by MUR. So let's run this together and see what it gives. So you see that now it has written MUR. So you are enhancing your graphic as you are seeing. Then I want to add another layer that will change the theme as you are seeing here. That theme is not very nice. I don't want that gray background. So I add another layer to that. And to change the theme, I can do something like theme minimal. There are, of course, other ways of doing, improving your themes. But right now I'm putting theme minimal, and you will see that it will remove that dark gray background, which is not very nice here. And we run that, and here we go. We got something like this. Okay, so here we are. We've got our graph. As you see, you can still improve it by improving the font size and so on, but I'm not going to get into all these details. The idea here is to introduce you to the ggplot, as you have seen. So you have understood for the time being. What we have done is that we are working our data in the form of a database. As you have seen, we are querying our data in the form of a database through dplyr codes. We are running, basically what we have done here is that we are running a database. We are running a table under a database, in a database in the memory of your laptop through the RAM that you have. And it is not saved permanently, it's just temporary, it's in your RAM, but you are just running a database in your RAM. If you want, you can just create a database and run this through that function by creating a database. Rather, by creating a table that you can use through memdb. These are things that you can do, and then when you have done that, the moment that you want to draw it, you need to convert it back to a table. And when you convert it back to a table, you get what the you can draw the g you can draw your plot. Now, just for information, you may ask yourself, why did I have to do that? I could have done it directly from the line df, which was already not the line, yes, which was already a table. There was no need for me to do all this. Indeed, you are right, there was no need for me to do all this to come to this step. I could have already drawn it right from the start, by the way. I could have already drawn it from right from the start, but the purpose of the class was also to introduce you to the concept of dbplyr, which is a database backed table that you can use, and it uses SQL translation, and it basically run SQL codes in the background. Now, what I want you to do is to do the following. I want you to do the same kind of thing, but maybe without getting into all the details of running them one by one, as you saw here. We don't even need to run the show query if you want. There's no need for that. If you want, you can do it. But what I want you to do is to obtain the top 5 products by revenue. A little bit what we have done already by revenue. But the only difference is that here it is running on a on in R in the memory. Same idea. So what I want you to do using dbplyr to do that. So take a small break. I mean, take a pause on the video and try to do it on your own. And then when you take, after having taken the pause, I'm going to give you the solution right now. So you take a pause, and then now after the pause, you can check your solution. So I'm going to say top products, and then I will use the same table that is a general table that I've used because I don't want to do the join or anything. I will just do that directly. I will use a pipe operator each and every time, where now I'm going to do a group by. This is what I'm doing. So we are going to group by the product name. We are going to order by the revenue, and we are going to get the first three or first five or whatever you want, and of course collect as usual, and all these. So we are going to convert that into an SQL, into a database, and then we are going to change it to. We are going to store it as a database and also convert it into uh, an R object, which is a table. So group by, and then I will use product name. There we go. Again, I will use a pipe operator. Summarize as usual. Then I will summarize by. I'll just copy that code normally because it's same thing. Summarize revenue, and I will add the pipe operator, just the same thing that we did. Summarize revenue, which is the same thing here, and then we are going to arrange, and the same thing, descending revenue, descending order of revenue. And I will just go directly, without going into all these details, directly to that step, which is to collect. You see, revenue campus, query, and then collect. I was doing it separately because I wanted to show you the query, but I will go directly to the collect now. And that is, I want to convert it directly in the form of a table that can be. So before the collect, everything is into form of a database. As soon as you do collect, now everything is turned into a table. So we run that, and then we run that. The project's not, the product not found. Let me just run this again. I think it was not run properly. There we go. And then we run that. You see here that we have a table. Here we go. Now what we want to do is to repeat the same procedure that I want to plot. I want to do the ggplot as I did earlier. It's just basically the same kind of thing. Okay, but yes, we want to do ggplot. So we are going to do that. We want to put the data table that we have, and then we put aesthetic as usual, and then in the aesthetic we will put our x is equal to, in our context, product name, and comma, we want the revenue here as y. This is what we have. And then when we have done that, we are going to add a layer. What layer? Again, as we did earlier. Maybe I will just copy that just to facilitate things a little bit. Geometrical. Then I will do lab title, and then I will give it a name, which is going to be top 5 products by revenue. And the same story, null, and it's not much different. We can run that, and you will see that this is what you get. Now, there are two problems here. You will see that, number one, not the problem, there is a main problem here, is that the data is given in the way that it appears here, not it appears, but in the form of alphabetical order as you are seeing, all right, in the form of alphabetical order. And it's not very nice because normally you would prefer to have blue ball pen to appear first, just like here it is ball pen, and then the next one is supposed to be notebook, and then the next one is supposed to be ceramic mug, but this is not the case here. So what you can do is that you can bring in an additional information here. Let me just find this out. Is that in the aesthetic, rather than having the data as it is in alphabetical order, in the aesthetic, you just mention something here. You say that you are going to reorder that product name, but based on revenue. Based on revenue. So you just change that product name based on revenue. So then you put comma revenue. And then of course put Y revenue as usual. So when you're doing reorder product name by revenue, this will ensure that the data, the plot is in the appropriate order. Okay, just run the whole thing. Let me escape that first. Yes, let me just run this again. Wait a minute, it's not running. Here we go. You will see that now it is blue ball pen, notebook, ceramic, USB, wireless, and UM UDI as it is. Now, by the way, if you want to, for readability purpose, you may wish to do something like you change the coordinate, you do a coordinate flip where you are going to put this bar chart in and as an horizontal bar chart rather than a vertical bar chart, just for the purpose of readability, especially if you have many levels here for products. Then you can add an argument, a layer just after geocol. It doesn't matter much whether you put it before or after, but normally I would put it after the geocol flip, and then I would do this. I would do code.flip, which means that I'm going to flip the coordinates that I've run. There we go. And then you get it in a better way, which is a vertical, which is an horizontal bar chart. That's some additional thing that maybe you have not done, and I'm just mentioning here. Let us take a look now at the daily revenue that we have. You would recall again from here that we have a daily revenue trend. So let me just find the trend and plot a graph which is going to be a time series graph in our example. Okay, to start with, so what are we going to do here? We are going daily revenue trend. We're going to plot the daily revenue trend. So to do so, we are going to repeat a little bit the same thing that we have done, but well, of course, there are certain things that will change. Maybe I will just copy that. There will be still the summarize, arrange, and the collect that will be there. So let me just copy that as it is. And here we go. So top products, it will change to daily revenue. I'm going to call it daily revenue. That will be my table that I want because I'm doing the collect at the end. It's again from the same table. We are going to group by, of course, not by product name, but rather by sale date. Just to ensure that we don't get it wrong, we copy the name here, sale date. Let me just find this out. Where is this? There we go. We're going to copy the sale date. Here they're going to group by sale date, and we are going to keep this as it is, summarize revenue, sum. So we are going to sum the line revenue by date, obviously, and we are going to arrange here not by revenue, but rather by date, which is the sales date. It's a little bit what I've done here anyway. Huh? Order by, group by date. So sum revenue, same thing. So we are repeating the same procedure here, and then we are going to collect. We run that. Very good. We can just check if you want quickly the daily revenue. You will get it as sale date, revenue, etc., etc. Now you will observe something. As soon as you converted that daily revenue to a table, look at the sale date. The sale date is no more in the form of a date that you are used to. What is this 20 for, what is this 2332 that you are seeing here? Um, the issue is that when R takes that date, it will convert it into double as you are seeing. It is not considering it as a date as such. And you have a small issue here, is that you need, when you're going to plot on your graphic, you will need to convert that back to um, a date. Okay. Now listen to me. Normally you would not have had all these issues if you did, if you um, didn't have to use if you didn't have to go through this line table as I mentioned here. If you didn't have to take this and make it become, where is it? If you didn't have to make it become a database, you would not have had these issues. You could just run it from this line df. It would work normally fine normally. It would not have any problem because we've already converted to date. But the issue that is arising here is that we are trying to do, like, we are converting it to a database, then converting it back to a table, which, bon, you will ask yourself, why are we doing that? As I repeat, it's just for the purpose of explaining to you what this um, database is, and at the same time I'm showing you the ggplot. But here the issue is arising because we are converting a database information of date to, it is converting it to num double. So we'll have to go back to that process where we convert that data again into that table double into a date. How can I convert it into a date, for example? So just for information, you see, if I tell you 20 30 20 30, 20,332, that is supposed to correspond to 20,332, that is supposed to correspond to, let me just find date here and then I show you what is supposed to correspond to. Where is it? It was already an issue here. Let me go. It is supposed to correspond to 2025 0901. So now the 1st September of 2025. Now the question is, how can I get it back to that data? Just for information, just for your information. Normally, R takes an origin as date, which is 1970 or 101. If you convert this, for example, let me just do it like that, as dot numeric, it will convert that as dot numeric. If you convert that date, we need to convert this as date. All right, inverted comma. I'm just showing you this. You will see that it gives you 0. Now, if we do the same thing, for us it is 1st September 9, 2025, isn't it? So 2025, 1st September 2025. Let us try this. You see, it gives you 20,332 days since the 1970. So the origin normally in R is like that. Why is it so? I don't know, but the origin is like this. Okay, that is 1970. So if you want to find, to convert it back, you will need to use that same origin that you have here, 1970 001, to convert it back to a date that is appropriate for us to plot on the horizontal axis. So how do I do? I will change the revenue that we have here from that table. I will change that. I will say dollar, which means that I'm going to use sale date again. I'm going to override the current one with that particular data structure. I'm going to override it. How am I going to override it? By converting it as date. Just as I did as numeric, now I convert it as date. I convert what as date? I convert the daily revenue sales from that table as date. But I need to give what is the origin. The origin is equal to, let's suppose, 1970, not let's suppose, but 1970 0101, as I mentioned to you. When you do that, you can run it, and then you can run your daily revenue again, Thibault, and you will see that now it has converted it back to date. You see? So that's one small thing that is a little bit annoying, but as I said to you, generally you won't be doing these things. All right, maybe you won't even be using at some point in time, you may not even be using this dbplyr, but I'm just mentioning it just for you to know that you can run a database in your R memory directly. Okay, this is just for your information, but the additional thing that I wanted to show here is that I wanted to show you those graphics as well, but there are some issues that arise because as I just mentioned, the uh, when it moves from the database to the table, we have a small issue in terms of date, for example, and we need to convert it back sometime. So this is some of the issues that we have. Now, what do we want to do now is the same kind of thing. We need to start with a ggplot. We want to run the ggplot. We will put the daily revenue, which is our table, and then we are going to put the aesthetic, which is going to be what do we want on the horizontal, what do we want on the vertical. Obviously we want the date on the horizontal, so it is sales date, and this is going to be at my x, and then we want the vertical to be the vertical to be obviously revenue. So we put that here. We can run this if you want, just to see what it gives you. And let me just run that. Sorry, where did I get it wrong? Yes, revenue. Revenue. Yeah, this is wrong as well. Just let me just check this quickly. So we have daily. This is not daily revenue. I don't know why. Yes, it is daily revenue. Um, this is aesthetic X is sale 8, and then Y is revenue. I closed everything. Just try this again. This is the issue that we have. We need to remove that equal, and let's run this again. Now you will see that you have your daily revenue prepared and the sales date down there properly written, September 02, September 04, and so on. Now we add the layer to the plot. What would be the layer? We are going to change now. We are not going to use geom color because we are not plotting a bar chart, but we are going to plot lines. So we use geom underscore line. The name are very easy to remember. You see, if you run these two, let's have a look. You will see that you will get your line graph as it is. Here we go. We can still improve. I'm not going to let me just do it. Labs. Okay, and then you put the title. We can call it daily revenue, and then we can call x equal to null, just to remove the sale date down there. If you want, if you want to keep it, you keep it. There's no need for you to do that. So x equal to null, excuse me, x equal to null, and then you want to say revenue is mu, because I'm already mentioning revenue in the title. And then as usual, I will just do an addition of the theme underscore minimal. I can run this now. It will be a better graph. Here we go. That's our daily revenue, which is presented to you as you see. As an exercise, what I will do is that I would expect you to do the revenue by payment method. You'll recall you've done this earlier. Revenue by payment somewhere. Bon, there we go. The revenue by payment. I would expect you to do the same thing. The revenue by payment. You are going to run the code using dbplyr and converting it to a table and plotting a bar chart. Obviously, that would be more appropriate. Just to conclude, I want to do something else now. I want you to compare each product's price to the overall average price. Okay, it's a little bit like the subquery that we have been running earlier. We have been running a subquery where I want to compare the each product's each product's price to the overall average price. I want to do something that will be in line with this. How can I do that? Let me come here. So uh, let's find the products priced above. Let me just write it like that. Products priced above the overall average price. So to do that, we will do, let me call it AVG price. And the average price, I will be using the line table, that is not the table, but the line table um, that is in our database. All right. And what I will do is that I will pass on the pipe operator as usual. Pipe operator, and I will say, okay, summarize, just like I did earlier. But this time, summarize not in terms of sum as I used to do here, but rather in terms of average. All right, in terms of an average. So how do I do that? I will say, first of all, I need to do the mean of unit price, the mean of unit price. So I need to check which product, uh, a what is the average unit price for uh, each of these different products. So I compute the average price and call it AVG price. We're going to compute the mean, which is going to be based on the unit price, the average unit price. This is an overall, how do we say, overall mean that is computed in the database. Computing the overall mean in the database. If you look at the, let me just go back to this, where is it? Line table. Let me just run this again. So I'm computing the average price. Where is it? Excuse me. Here we go. Let me just run this again. Find the table. So you will see that the unit price, I'm doing an average of a unit price to be able to know, as I mentioned to you, sorry. As I mentioned to you, that I want to know what are the products priced above the overall average price. Okay. If I want to do something like that, I'll just run something like a summary of average price of a unit price. Okay. And then I can run that if you want, just to know what is the average price. The average price is 473. Anything that is above that will be considered higher price. Anything that is lower that will be considered lower price. So you know that what product is going to be normally considered to be above the average unit price, or which product is going to be considered below the average unit price. Now, the only issue with that average price is that you will see that it writes all these different information sources database, but I just want the value 473 because that value 473 will be used later on to be able to give me the products which have the which for which the unit price is above the mean unit price. So then what I do is I will do an additional pipe here where I'm going to use a pull function. The pull function will just basically uh, draw only the value, that's all, not all these different information. So if you run this again, average price, you will see that it gives me 473. That's the only value that I want to be used later on. So let's continue. I will now obtain the above average products. It's like a table that I will get, which are the above average products. And again, it will be from the line table that I'm going to draw these information. And then I will do a group by as usual and a summarization, again, a summary. So let me just group by and summarize. I will explain to you what I'm going to do there. So the group by is going to be by product name, because this time I'm not going to group by anything except by product name, group by product name. And then I'm going to do summarize unit price. Unit price is equal to maximum of unit price. What I'm doing here, I'm just trying to get by product name to give me the maximum. What does it mean to give me maximum? It means that it will, because you see, product name is repeated several times. You have notebook A5, notebook A5 that is occurring uh, several times in terms of unit price. So 60 is repeated 7 times. So what do I want to do? I want to do a summary where I'm going to take only the maximum. For example, 60. Now, listen to me. I could also not use a maximum. I could have used a mean as well, because if I use a mean, I will get the same value each time because I know that these values are repeated. So using the mean would be fine. Even using the minimum would be fine. It's all fine. Because here, when I'm doing this function, basically I'm doing the summary by taking only a single value, and that would be the maximum, irrespective of what it is here. In any case, the maximum will be the same value, like the minimum will be the same value like the mean in this context, okay, because it's uniform, it's repeated value here. So it doesn't matter whether you put mean, whether you put minimum, whether you put maximum, it's all fine. Max is fine in this context. So let me just run that, for example, just to see what you get. You will see that now you get only the products that are not repeated because you have summarized, and you get their respective prices in a form of a table as you are seeing here. But me, what I'm interested is not this whole summary, because I'm interested in all those for which the price is above 473. So the price for which is above 473 would be, for example, 1,200, 600 would be considered in hoodie, wireless mouse will be considered. So how do I do that? That's where I used another function that I was mentioning earlier to you. For example, where is it? I mentioned that earlier, we use arrange, but there is another function called filter, and I'm going to use that filter here. So we do filter. Filter is just like the where close in in SQL. Sorry, you filter any unit price being above that average that you have computed earlier. You filter by the average that you have computed earlier. That will yield the unit price. So let me just run that. You will see again. I run the average product again. And now you see that you have only hoodie and you have the wireless mouse. Okay. Now, this is okay. And then you can go for here. The advantage is that it is already in order. You have in order of alphabetical order, and the alphabetical order gives you the first as 1,200 and 600 per second, but normally you would have had to do an arrange just after that. Okay, if this was not the case, you would have had to do an arrange uh, and then arrange descending order of unit descending order for unit price. You remember the arrange function that you had here. You would have had to write that and then unit price here, and then you would collect. But in our context, there is no need for that. If you want to, I just do collect directly, and this will give me only the two values here, only the two rows here. So let me just run this again. Here we go. We get only these two rows, as you see. It's now a table, and of course, from that table, you can again, of course, draw a diagram, etc. Are reaching the end of our class today, and you need to I would like you to do something now, just something else. You have done it for average price product. Maybe what I want you to do is to obtain the with campuses with more than three distinct sales. Okay, with more than three distinct sales. So for that, I'm just going to give you a small hint that you may not be aware of, is that in the summarize function, you have used mean, you have used max, you know all these different things that you have used here, mean, max, you have done sum, but if you want a distinct, you need to use that function distinct and distinct. And obviously, you will need to do it distinct by sales ID, by sale ID. That's the only trick I gave you. If you use that in the summarize function, you should be fine and you'll be able to get the campus with more than three distinct sales. But I'm not going to do it now. In any case, I'm going to send you the code, and the codes will be including this as well. So what did we do right now in the second part of this video, as you are seeing, is that we understand that the dbplyr um, lets us rather keep the relational thinking while we are just writing dplyr codes. You see, all these are dplyr codes, but it keeps us with the relational thinking that is going behind, with this group by, with all these different things as well. Uh, and if you want to see what's going on behind the scene, you can use a show query. I did not do it each time, but that will keep you abreast with regards to, for example, here, if I do a show query, let me do this, for example, show query above average product, that will give us an idea of what's going behind the scene. So if you want to use your dplyr, and so let me just check what has happened here. Sorry, it has already been converted to a table, excuse me, that's why you can't see it. But before you convert it, before the collect, before the collect, let's suppose I delete that and I run this whole thing again, you will see that it will give me what's going on behind the scene. You see, because I've done the collect, that's why it's not correct. Okay, the collect is going to convert to a table, so you see what's going on behind the scene. So it keeps you with the idea of what's going to happen when you are doing this using dplyr, what's going on behind the scene using structured query languages. So you can translate that into structured query languages and get an idea of what's going on. If this table was in, for example, in MySQL, if you had the table line revenue in MySQL, if you run that as it is right now, it would be as if you are running that. So if you want, you can just copy and paste that particular code and bring it into your MySQL and run it there into your MySQL and run it there. And normally it will give you the same thing that if you were to use these different codes that we have seen here. So that's something that we wanted to show you, bearing in mind that normally this is not necessary if you want to do something more advanced. This is quite basic, and it's just to keep you as if, as we can say, SQL literate. That's all it is doing. Um, and we have seen also that when you are doing the collect, it converts it into a table, which we can draw our diagram from that. If you did not do the collect, we will have some difficulties to draw the diagram because we need to convert that database into an R object, as you have seen. And the other thing is what we are going to do later is that we will switch to what we call DBI, and DBI is another package that we are going to use at some point in time that will enable us to connect our SQL directly with this SQL. We are going to run our code directly in R, but this will come later. In fact, it will be, you will see that it is more in line with what you are doing, but right, not in line, but more interesting, if I can say. But here, this was just to give you an idea of how you can run a database in R using dbplyr, using our usual dplyr verbs that you have been seeing last time. So that's a little bit the closing remark. So we've done quite a number of things today, including the dplyr. We have also seen how to run joins and all these different things. So uh, take some time to assimilate all these details. Thank you for your attention and see you in class later.